Welcome to the Docker full course by Simplilearn. In this comprehensive course, we will guide you through the essential of Docker, starting from the very basic to advanced concept. So what is Docker? In simple terms, Docker is a tool that allows developers to package application and all their dependencies into a standardized unit called a container. This makes it easy to run the application consistently on any environment, whether it's your computer, a server, or the cloud. You will learn how to install Docker on both Ubuntu and Windows 10. We'll also explore Docker containers and the benefits they bring to your application development and deployment. You will also get hands-on experience with Docker Swarm for managing cluster and Docker Compose for defining multi-container application. Additionally, we will cover how to create Docker files for building images, execute essential Docker commands, and Dockerize any application step by step. Networking is crucial in containerization, so we will guide you through Docker networking tutorials as well. We will also compare Docker with Kubernetes and virtual machine to understand their rules in model development environment. Lastly, we will prepare you for the success with Docker interview question and answer. Get ready to dive deep into the world of Docker. Also, if you are looking forward to make a career in DevOps, definitely check out Simplilearn's professional certificate program in cloud computing and DevOps. This comprehensive course offers in-depth learning with a thorough understanding of cloud computing principles and DevOps practices, guided by expert instructor with real-world experience. You will engage in hands-on projects and real-world scenarios, building a robust portfolio that showcases your skill. Plus, the program is designed to help you gain industry-recognized certification, making you a standout candidate in the job market. So don't forget to check out the course link from the description box below and the pinned comment.
Back in the day when Netflix was just starting to hit its stride, they faced serious challenges managing their growing infrastructure. Keeping millions of people happy, streaming movies and shows without interruption, it was not an easy task. Initially, Netflix struggled with scaling issues, monolithic architecture problems, and deployments bottlenecks. Their infrastructure couldn't keep up with the increasing user demand, leading to frequent downtimes. The monolithic architectures made it difficult to update or scale parts of the system without affecting the whole. Deploying new features was slow and risky and often causing service disruptions. And that's when they discovered microservices, which allowed them to break the application into smaller and more manageable pieces. This meant that they could tweak and tinker with different parts of the service independently, and greatly improving flexibility and reliability. Complementing microservices with DevOps practices like continuous integration and deployment, Netflix transformed their operation, ensuring seamless streamings for users worldwide. So next time when you binge watch, remember this epic journey they took to get there. Now before we move on and learn more about DevOps, I request you guys that do not forget to hit the subscribe button and click the bell icon for further updates. So here's the agenda for our today's session. We are going to start our session with an introduction to what is DevOps. Then we will learn about why DevOps. Moving ahead, we will discuss principle of DevOps and phases of DevOps. Then we will deep dive into DevOps tools. And finally, we are going to conclude our session with a hands-on. So guys, let's start with what is DevOps. Guys, DevOps is an innovative approach to software development and IT operations that emphasizes collaboration, automation, and continuous improvement. The goal is to bridge the gap between developers who write the code and operations who deploy and manage it, leading to faster, more efficient production cycles and deployments. So this was a basic definition of DevOps. Now, I hope so you have got a brief idea regarding this. Now let's move on and understand why DevOps. So guys, understanding its impact on traditional software development and shift to microservices, DevOps has become an essential methodology in modern software development, primarily addressing many of the inefficiencies found in traditional development and operation model. These traditional models often feature siloed structure where development and operation teams have distinct, separate roles and responsibilities. This separation can lead to various challenges like the slow production cycles. With development and operations working separately, the transition from code completion to deployment can be slow and cumbersome. There is a lack of integration between these teams and often result in longer release cycles. Next issue with the traditional setup was the deployment issues. When developers and operations work independently, there is a higher chance of encountering problems during deployment, such as configuration errors, environment discrepancies, and unexpected behavior in production. And also they had limited feedback loops. Like in the traditional setups, feedback from the operation teams regarding application performance, user issues, or system failures might not reach to developers quickly, and thus delaying the necessary fix and improvement. Now there was an introduction of microservices where we got enhanced scalability, increased development velocity, and flexibility when compared to traditional setups. Now let's look at a case study of a financial firm and how DevOps helped them. So guys, consider a financial firm who is struggling with the deployment cycles and poor feedback mechanism in their traditional development setup, leading to delayed product updates and frequent outages. So what's the solution? As we have discussed earlier, microservices. In DevOps culture, so as a solution, they implemented a DevOps culture fostering closer collaboration between developers and operation, and also establishing a continuous integration and continuous deployment pipeline. By the adoption of microservices, they split their large cumbersome financial processing system into smaller and manageable microservices. And what's the outcome, guys? The continuous improvement. The CI/CD pipelines allowed for regular updates and minimal downtime. Each microservice could be updated independently and facilitating faster and safer deployments. There was enhanced feedback loops. So monitoring tools specific to each microservice provided rapid feedback directly to the respective development teams, which allowed for quicker responses to the issues and more informed decision making. So this was the overall benefits of applying a DevOps culture in a financial firm. And they had two success outcomes. The first one was they adopted a DevOps culture, which helped them a faster delivery, and there was adoption of microservices, which helped their applications succeed and also improve the user experience. Now let's move on and try to understand that what are the principles of DevOps. So guys, the core principle of DevOps are laid as follows. Initially, DevOps is founded on several key principles that streamline and enhance the processes involved in software development and operations. The first one is automation. Second one is CI/CD. And the third one is rapid feedback. Now let's understand each one of them one by one. Now if I talk about automation, guys, so automation in DevOps covers everything from code deployment to environment setup and network configuration. For example, using a tool like Ansible, you can automate the deployment of application across hundreds of servers, eliminating manual setup and ensuring consistency across your infrastructure. Next one we have is continuous integration and continuous delivery. Let us first discuss about continuous integration. So here, developers merge their changes back to the main branch of the project as often as possible. These changes are validated by creating a build and running automated tests against them. For example, using Jenkins, a CI server which automatically tests the build whenever new commits are pushed to the main repository, ensuring that new code integrates well with the existing code base. Now, if I talk about the continuous delivery, guys, it extends the continuous integration by automatically preparing and tracking a release to the production. This ensures that you can release new changes to your customers quickly in a sustainable way. For example, Travis CI can be configured to deploy applications automatically to the production environments. Whenever the build stage in the CI process is successful, it is provided by all the tests that it has passed. Now let us discuss about the third one, that is rapid feedback. So guys, what does it involve? It involves implementing feedback mechanisms quickly and identifying and addressing issues in the development of production environments. For example, we have New Relic, which can be used to monitor applications in real time, providing immediate feedback to developers if performance degrades or an error occurs. So these were some of the basic principles of DevOps. I hope so you got an idea regarding this. Now let's move on and discuss one of the most important points, that is phases of DevOps. So guys, if we discuss the phases of DevOps, understanding the life cycle in DevOps is crucial to grasp how it benefits the software development and operation process. And you should understand one thing, that DevOps is not a tool. DevOps is a practice that we apply in our software development. So the first one is plan. The planning phase involves defining the project scope, identifying resources, and scheduling timelines. For example, Jira for task management, and sprint planning, which helps in tracking the progress and prioritizing the work items. Next we have all over here is code. Developers write code in small, manageable chunks to ensure that integration is simpler and more frequent. For example, we are using GitHub, a version control system where developers can collaborate to track changes and revert to previous states if necessary. The third one is build. The build phase involves transforming code written by developers into a runnable instance of the application. For example, Gradle or Maven, which can compile code and manage the dependencies. The fourth one is testing phase. Automated tests are run to ensure the application behaves as expected. For example, Selenium for automated web testing and ensuring that user experience is consistent across different devices and browsers. Next one we have is release. So guys, the release phase involves activities related to deploying the software to production, ensuring that the software is released in a controlled manner. For example, Docker, which can package the application and its environment into a container that can be deployed consistently in any environment. The next phase is deploying. The actual deployment of the application to a production environment where it can be accessed by the users. For example, we use tools like Kubernetes, which automates the deployment, scaling, and management of the containerized applications. Seventh one is operate. Ongoing maintenance and regular updates of the application are happening at this stage. For example, we have Ansible for configuration management, ensuring that all systems are consistent and maintained in the desired state. And finally, it's monitoring. Continuous monitoring of the application to ensure it performs optimally and to detect and resolve issues as they arise. For example, we have Prometheus for monitoring application performance and Grafana for visualizing the data collected. So these were some of the phases of DevOps. So guys, in the interviews, someone can ask it. So just keep a thorough note of this. Now let us move on ahead and understand DevOps tools and their capabilities. For example, we have the version control system. Version control systems like Git allow the teams to track changes and revert to previous version of their work and manage code with a minimal conflict between the concurrent efforts. For example, we have the tool like Git, which allows to do version control system. Next, we have CI/CD tools. So guys, we have CI/CD tools like Jenkins, CircleI, GitHub Actions, which automate the stages of CI and CD, facilitating the frequent and reliable code changes by automatically compiling, testing, and deploying the code. Then we have the configuration management, where we have tools like Puppet, Chef, and Ansible, which automate the provisioning and management of your computing infrastructure and application. They ensure environments are set up consistently and are repeatable. Moving ahead, we have monitoring and logging. So guys, tools like Elasticsearch, Logstash, and Kibana, and also Splunk collect, analyze, and visualize machine-generated data to provide insights into application performance and health. So guys, these were some of the DevOps tools. And I hope so you have got a brief idea like how they are incorporated in DevOps. Now let's move ahead and do a small hands-on and let us see how can we incorporate these tools into DevOps practices. So guys, let us create a hands-on beginner DevOps tutorial where we are going to set up a basic continuous integration and continuous deployment pipeline using GitHub Actions. And in this tutorial, we are going to show you how you can automate the testing and the deployment of a simple Hello World Python application. Now, there are certain prerequisites for this. You need to have a GitHub account and have a little bit basic familiarity with Git and Python. You can access any text editor like VS Code or Sublime Text. Now, let us go on to the step number 1. Let us first create a new repository on GitHub. Okay, so I have logged into my account, okay, and here I'm going to click on the new. So here's our new repository, and our repository name is going to be, let's say, Hello World CI/CD. So Hello World CI/CD is our Git repository. Now make sure that you make it public. Okay, that's very, very important because now initialize a repository with a README file. So here you can add a README file all over here. And also you can set up a description that this is a demo CI/CD project. Okay. Now, since you have done all this thing, just click on create repository. So our new repository is going to be created. Okay. So it says the world is not family. Okay, we are going to change the name. Say hello world. Okay. Now let us create the repository. Pretty fine. So you can see our repository is created. Now let us do one thing. Now we are going to set up our local environment. For that, you need to have a git bash in your system. Now let us clone the repository. Okay. So what we are going to do. So let us copy this. Okay. And let us go to our bash. And here, let us first create a directory. So let us create mkdir and let us give a name of CI/CD, or we can say it demo. Okay. Then let's move to that directory. Okay, pretty good. Now in this, I want to clone it up. So for cloning, you need to do just add git clone. Okay. And add the given link. Pretty fine. Now just click on into it and you can see it has started cloning the given directory. Now let us move to this directory, which is hello world. Okay, so I'm just gonna copy this and say cd plus paste this. Okay. Now you can see we are in our main branch. Now all over here, so as you can see, we have navigated to this directory. This is our main, and cd hello world is our main parent branch. Now after that, what you have to do, let us create a basic Python application. Okay, so I have already created that for you. So you can see there are two files. First one is app.py and second one is test app.py. So this is a hello world CI/CD. Okay, but we need some different directories. So let us open the folder first. Okay, let us see. Okay, we can see demo here. Okay, so you can see we have opened our directory hello world all over here, and here we are going to create a file name app.py inside this repository. So no worries, just click on this folder and click app.py. Okay, and this is our app.py, and inside this let us write a Python code. So basically let's create a function, say def hello world. Okay, a function that just prints hello world. And inside this, I want to say let's return hello world. Pretty fine. Now let's move ahead and let us write our function. So this is very basic. So if name, let's say it's equal to, say, main. Okay, and we can print the hello world. So let us call our function hello world. Now we have created a basic app.py file. Now the next thing what we are going to do, we are going to commit. Okay, so let us add this file. So let us open our git bash and say git, okay, and say git add app.py. So this file has been added, and let us commit a message. Okay, so git commit and m, and let us say add hello world. Okay, so this is our message. Now finally moving ahead, what I'm going to do, so you can see committer, my name is given and your name and email address configured automatically on your username and hostname. So it says, and after doing this, this has been committed. Now let us push this. So git push. So you can see it's easily being pushed up. Now the fourth part is testing. So we are going to create a test file all over here. So basically in this, we are going to do a unit test, and which is going to test the hello world function. So if you are aware of unit testing, it's fine. And if not, you can check on our channel. There are a lot of videos regarding unit testing. It might help you out. So guys, here, let us create this test app.py. Okay. And here I'm just gonna paste this. So it is unit test you can see I'm importing our application app, and here is hello world is imported from this file, and here the class test app is there, and here basically we are doing a unit test. So in this, I'm asserting that hello world is, whenever we are calling this function, it prints up the hello world. And finally, we are defining our main function. Very easy. And after this, let us add commit to this file. Okay, basically to our repository. So what we are going to do, we are going to add this file in our repo. So let us control, pretty fine. Now let us git add, and we can test app.py. Okay, it says our app file is not named like this. Let me check. So test app.py. Okay, is it inside this directory? Okay, something is wrong. So no worries, I have okay. Now in here, I'm gonna, okay guys, so my file was out of the repository, so I included in this. Okay, now let us go to our terminal. Okay, and let us retry to add. Okay, now you can see this would be easily committed. Now, and after this, let us commit it. So git commit m, and let's say add test for hello world application. Okay, and let's just click on it, and you can say this is committed. And finally, we'll push it up. So you can see it has been easily pushed up onto our repository. Now, the step 5 would be creating a GitHub action for CI/CD. So let us navigate to our repository first, and if you refresh this, we could see we have added a readme file, app.py, test app.py. Okay, now in this repository, we have to navigate to the actions tab and click and create a new workflow. Okay, so here you can see this actions button, just click on this. So in this, let us set up our new workflow. Okay, so basically we are going to create, like, the file would be main.yml, and YML file that you have to put all over here. So let me share you with this. So guys, as you can see, this is our main.yml file. Okay, and the content inside this looks something like this. Okay, so you can see all over here. Now let us try to understand this file. So basically you can see the name of this application is Python application CI/CD. So we have created a workflow file for this. So it says on. So basically on defines the event that is going to trigger the workflow. Then you can see there is push. Basically this workflow will trigger on the push events to the main branch. Then you can see there is a pull request, and the workflow will also trigger on the pull request to the main branch. So basically these triggers are going to ensure that every push and pull request to the main branch initiates the workflow, which is common practice to ensure that the main branch remains stable and deployable. Now you can see all over here, there are jobs. Okay, so like build, YML, copy code, jobs, and these things are there. So basically jobs defines a set of jobs that the workflow will execute. Jobs run in parallel by the default unless it is specified. Now you can see build, this is a single job and it is identified by the key build. It includes several steps that this job will execute. Then you can see runs on. Okay, so this specifies the type of virtual machine to run the job on. So here we can see that here is the machine is Ubuntu latest. It basically indicates the latest Ubuntu runner which is provided by the GitHub action. Then there are steps. So inside the steps you can see we have the users written actions /checkout at v2 name setup Python, and there are users action setup Python v2 with Python version 3.8. Now here you are going to install your dependencies, then you are going to run, And finally, we are installing Python m pip install upgrade pip. So basically steps, what does it mean? It's a sequence of tasks that will be executed as a part of the job. Okay. In the uses action slash checkout at the rate v2, basically this step uses the checkout action to check out the repository code so that the workflow can access it. Okay. Then we are setting up Python 3.8 and it uses the action setup at the rate Python version v2. Basically, it is initializing the setup Python action to set up a Python environment with specified parameters to pass the action, such as the version is 3.8. So this overall sets up the Python version 3.8. Then we are installing the dependencies. So there is a run command. So basically it executes a command using the shell in the run environment. And this script updates the pip and install the unit test module, although which is typically unit test is a part of Python standard library and it does not require installation via pip. Okay, that's one additional thing I want you to know. And finally, we are testing our application with the unit test. Okay, so this step runs the Python's unit test module in the discovery mode to find and run the test. Then there are vflag, which is for the verbose output, and which is going to display all the tests being run on their results. So this configuration ensures that every change that we are pushing to the main branch or made in a pull request is automatically tested, and it is maintaining the code's integrity and functionality. The CI/CD pipeline helps automate the testing and the deployment. It is very essential practice for efficient and reliable software development, and which is generally followed in the industry. So I hope so you have got a brief idea regarding this. Now we have completed our setup. So what's the next thing we have to do? So we have to go all over here and just click on commit changes. So it says create via main.yml and we can see that we have created this. So guys, as you can see in this main.yml, you can see we have created our workflow all over here and we have created our CI/CD pipeline using the GitHub Actions for the simple Python application. This pipeline automatically runs your test every time the changes are pushed to your repository, demonstrating a foundational DevOps practice. This fundamental step towards more complex DevOps processes involves larger applications and more integrated testing and deployment environments. So guys, this was a basic CI/CD setup. I hope so you have got a brief idea regarding this. If not, you can comment on this and our team of experts are going to reach out to you.
If you are here, you're probably wondering how to become a DevOps engineer. Well, you are in the right place. Today, we are diving into the ultimate DevOps engineer roadmap. DevOps is all about blending development and operations to streamline and speed up the entire software development process. DevOps engineers are in hot demand and the salaries are pretty amazing too. Depending on your experience and where you are, you could be making anywhere from $90,000 to over $150,000 a year. So stick around. In this video, we'll walk you through the ultimate roadmap to becoming a DevOps engineer. We'll cover everything you need to know step by step to help you succeed in this fantastic field. So these are the contents that you must learn to become a DevOps engineer. So better take a screenshot of this. So first up, we have the Software Development Lifecycle or SDLC. So the software development lifecycle is a process used by the software developers to design, develop, and test high-quality software. It consists of several stages. Each stage helps ensure the software is reliable, functional, and meets user needs. So understanding SDLC is crucial because it gives you a holistic view of software development. It's like knowing the recipe before you start cooking. So the different phases of SDLC are requirements gathering, understanding what the stakeholders need, design, planning the solutions architecture, implementation, which is writing the code. Then comes testing, which is ensuring the code works as intended. Then comes deployment, which is releasing the software to users, and finally maintenance, which is updating and fixing the software as needed. So each phase has its own importance, and knowing these phases helps you understand how DevOps practices integrate to make the development and deployment processes more efficient and reliable. So next, let's talk about Linux. Linux is a type of operating system like Windows or Mac OS that runs on many servers, computers, and devices around the world. It's known for being stable, secure, and free to use. But why Linux? Because it's the backbone of most server environments you'll work with. Here are the essentials you should focus on. which are command line operations, shell scripting, learn bash to automate repetitive tasks, system administration like understand how to manage users, permissions and processes, and package management. So Linux is used everywhere in the server world, and knowing it well will help you fix problems, automate tasks, and manage servers easily. Now, the next one is learning a scripting or programming language. So knowing a scripting language like Python, Ruby, or even Bash is essential. These languages help you automate tasks, write scripts, and manage infrastructure. So here's why you should learn scripting. Automation. Write scripts to automate repetitive tasks such as backups, deployments, and monitoring. Configuration management. Tools like Ansible use Python for automation. Infrastructure management. Use scripts to manage cloud resources, databases, and more. So choose a language and start building small projects to get hands-on experience. I highly recommend Python due to its simplicity and extensive libraries. Now, Git is next on our list. Git is the most popular version control system out there. It allows you to track changes, collaborate with others, and maintain a history of your code. So key concepts to learn include repositories, how to create and manage them. Commits, recording changes to the repository. Branches, which is working on different features simultaneously, and merging, which is integrating changes from different branches. So familiarize yourself with platforms like GitHub, GitLab, and Bitbucket. These platforms facilitate collaboration and code management in a team environment. Now, networking and security are critical components of a DevOps engineer's skill set. You'll need to understand how data flows through networks, how to set up firewalls, and secure your applications. So, focus on these areas. Basic networking. Understanding IP addresses, DNS, HTTP, HTTPS, and TCP/IP protocols. Network security. Learn about firewalls, VPNs, and encryption techniques, and application security. Implement security best practices such as input validation, authentication, and authorization. So this knowledge will help you build secure and reliable systems, ensuring data integrity and confidentiality. Now let's move on to cloud providers. So AWS, Azure, and Google Cloud Platform are the big players here. So start with one and learn the basics. So number one, compute services like EC2 AWS, VMware in Azure, and Compute Engine in GCP. Then comes storage services like S3 in AWS, blob storage in Azure, and cloud storage in GCP. And then database services like RDS in AWS, SQL database in Azure, and Cloud SQL in GCP. So understanding cloud services is crucial as most modern applications run on cloud infrastructure. So learn about IAM, which is Identity and Access Management for security, and explore cloud-specific services and tools offered by these providers. Now next, you need Infrastructure as Code, or IAC, which is a game changer. So infrastructure as code is a way to set up and manage computer resources like servers and networks using code instead of doing it by hand. So you write scripts that describe what you need, and then tools like Terraform or Ansible read these scripts and set everything up for you automatically. So this makes it easy to create, update, and keep everything consistent every time. This means you can version control your infrastructure just like your application code. So the key benefits include consistency, which ensure that environments are identical. Then scalability, it easily replicates environments across multiple regions. And then version control, which track changes to your infrastructure over time. So you can start by writing simple Terraform scripts to provision resources, or use Ansible to automate configuration management. Now next up, we have microservices and containers. So microservices architecture allows you to break down your application into smaller independent services. So containers with tools like Docker package these services and their dependencies, ensuring they run consistently across environments. So you should definitely focus on microservices, which is understand the principles of designing and building microservices. Then Docker, learn how to create Docker files, build images, and run containers. And then container registries. So use Docker Hub or private registries to store and share images. So these concepts will help you build scalable and efficient applications that are easy to deploy and manage. Now following containers, we have container orchestration. So Kubernetes is the go-to tool here. It manages the deployment, scaling, and operations of containerized applications. So the key components that you need to learn of Kubernetes are: number one, pods. The smallest deployable units that can contain one or more containers is called pod. Next, services. networking components that define a set of pods and a policy by which to access them, and then deployments, which are controllers that manage the desired state of pods. So learning Kubernetes can be challenging, but it's incredibly powerful. It automates many operational tasks, allowing you to focus on building great applications. Now moving on to next, continuous integration and continuous deployment, or CI/CD, are at the heart of DevOps. So tools like Jenkins, Circle CI, and GitLab CI help automate the process of testing and deploying code. So here's why CI/CD is crucial. Continuous integration automatically tests your code to catch issues earlier. Continuous deployment, it automatically deploys your code to production, reducing time to market. And then pipelines, it defines the steps to build, test, and deploy your application. So mastering CI/CD will make your development process more efficient and reliable, allowing for faster and more frequent releases. So next, monitoring and logging. So monitoring and logging are essential for maintaining and troubleshooting your applications. So tools like Prometheus, Grafana, and ELK Stack, which is Elasticsearch, Logstash, and Kibana, provide insights into your system's performance and help you diagnose issues. So you must focus on metrics, which is track performance metrics like CPU, memory, and network usage. Logging, collect and analyze log data to troubleshoot issues. Alerting, set up alerts to notify you of potential issues before they become critical. So by setting up proper monitoring and logging, you ensure your systems run smoothly and can quickly respond to any problems. So now, DevOps is not just about tools and technologies. It's also about people. So collaboration and communication are crucial. You'll be working closely with developers, operations teams, and other stakeholders, which mean you must definitely focus on communication tools, like start using Slack, Microsoft Teams, or other tools for effective communication. Then comes project management, so utilize tools like Jira or Trello to manage tasks and projects. And then you must develop soft skills, so develop empathy, active listening, and clear communication to work effectively in a team. So being able to convey ideas clearly and work effectively in a team is a key to your success in DevOps. So finally, let's talk about leadership and strategy. So as you grow in your career, you may take on more responsibilities and lead teams. So understanding the strategic aspects of DevOps, such as implementing best practices, driving cultural change, and aligning DevOps initiatives with business goals is crucial. So focus on best practices. Implement and advocate for DevOps best practices within your team. Next, cultural change. Foster a culture of collaboration, continuous improvement, and learning. And then strategic alignment. Ensure DevOps initiatives align with business objectives and deliver value. So leadership skills will help you inspire and guide your team towards success, making a significant impact on your organization.
In this video, we'll explain why you should choose DevOps as a career, go over different job roles, and map out a clear career path for you. We'll also talk about salary potential and many growth opportunities in this exciting field. Whether you are new to tech or have some experience, this video will give you all the insights you need to succeed in a DevOps career. Let's get started. DevOps is all about breaking down the barriers between development and operations team. It's a culture, a set of practices, and a bunch of tools that help companies deliver better software faster. Think of it as a secret sauce that makes tech companies super efficient. In the old days, developers would write a code, throw it over to the wall to the operations team, and hope for the best. With DevOps, everyone's working together from start to finish, and everyone's on the same page. Now, you might be wondering, why should I choose DevOps as a career? Well, buckle up because I've got some compelling reasons for you. Number one, high demand. DevOps skills are in high demand. Companies are constantly looking for professionals who can bridge the gap between development and operations because they've realized it's the key to staying competitive in today's fast-paced tech world. Number two, versatility. DevOps roles offer a lot of versatility. You get to work on a variety of tasks from coding and scripting to managing infrastructure and improving security. Number three, broad skill set. DevOps allows you to develop a broad skill set, including automation, cloud computing, containerization, monitoring, and security. This diverse skill set enhances your marketability and opens up various career paths within tech industry. Number four, innovation. If you love innovation and problem solving, DevOps is for you. You'll be at the forefront of new technologies and practices. And number five, job satisfaction. Many DevOps professionals report high job satisfaction due to the dynamic and impactful nature of the work. Now, let's map out a typical DevOps career path. Remember, everyone's journey is unique. but this should give you a general idea. Start with the basics. Learn the basics of programming, networking, and system administration. Languages like Python, Ruby, and scripting skills are crucial. Then, get certified. Certifications like AWS Certified DevOps Engineer, Google Professional DevOps Engineer, or Azure DevOps Engineer can give you a competitive edge. Next, gain experience. Work on real-world projects. You can start with internships or entry-level positions to build your experience. And then keep learning. DevOps is an ever-evolving field. Stay updated with the latest tools and technologies and continuously enhance your skills through courses and certifications. And lastly, network. Join DevOps communities, attend meetups, and connect with professionals in the field. Networking can open up new opportunities and insights. Now let's talk about how your career might progress in DevOps. Trust me, it's an exciting journey. Junior DevOps Engineer. So generally you start as a junior DevOps engineer, learning the basics of automation, CI/CD pipelines, and infrastructure as a code. DevOps Engineer. With experience, you move up to a DevOps Engineer role, taking on more responsibilities like managing large-scale deployments and monitoring systems. Senior DevOps Engineer. So as a senior DevOps engineer, you lead projects, mentor junior team members, and work on optimizing the entire DevOps lifecycle. Then comes lead DevOps engineer or lead DevOps manager. So eventually you can become a lead DevOps engineer or a manager, overseeing teams, strategy, and the implementation of DevOps practices across the organization. But then everyone has a different starting point, right? You might be a total fresher or a software developer or even a network engineer. So now we will see what your career progression will look like according to your current job roles. So number 1, systems administrator. So if you start as a systems administrator, you're already skilled at managing and maintaining IT infrastructure. Transitioning to DevOps involves learning about automation tools like Ansible, Chef, or Puppet, which help in automating routine tasks. You'll also need to get familiar with CI/CD, which is continuous integration, continuous deployment pipelines, which streamline the process of integrating and deploying code changes. Your experience with servers, networks, and troubleshooting is incredibly valuable because in DevOps role, you'll be automating infrastructure management and ensuring smooth deployments. Next, software developer. So starting as a software developer gives you a strong foundation in coding and development practices. So to move into DevOps, you'll want to learn more about CI/CD tools such as Jenkins, Circle CI, or GitLab CI. So these tools help automate the integration process and deployment of code changes. Additionally, you should get comfortable with infrastructure as a code tools like Terraform, which allow you to manage your infrastructure using code, and cloud platforms like AWS, Azure, or Google Cloud. Now, your development skills are crucial for automating processes and integrating development and operations workflows seamlessly. Next, test automation engineer. So as a test automation engineer, you already have expertise in testing frameworks and automation. So transitioning into DevOps will involve expanding your knowledge to include continuous testing within CI/CD pipelines. You'll also need to learn about Docker for containerization, which makes it easier to manage and deploy applications, and Kubernetes for orchestration, which automates the deployment, scaling, and management of containerized applications. So your background in ensuring code quality and automating tests is key to maintaining the reliability and performance of applications in a DevOps environment. Next, network engineer. So starting as a network engineer means you have a deep understanding of networking, security, and infrastructure. So moving into DevOps will require you to learn about automation tools and scripting languages like Python or Bash. So you should also familiarize yourself with cloud networking services and software-defined networking. Your skills in managing and optimizing network performance will be crucial for creating scalable and secure DevOps practices. So in DevOps, you'll be automating network configurations and ensuring that the infrastructure supports the rapid development and deployment cycles. So now let's talk about money. So the good news is that DevOps professionals are in high demand. So that translates to some pretty good salaries. So according to recent data from Glassdoor, the average base salary for a DevOps engineer in the US is around $107,000 per year. And that's just the average. Experienced pros can easily command up to $150,000 or more. So of course, salaries vary depending on factors like location, company size, and your level of experience. So finally, let's explore the growth opportunities in DevOps. And let me tell you, they're pretty exciting. So as already discussed, one of the great things about DevOps is its versatility. You can specialize in areas like cloud computing, cybersecurity, or artificial intelligence. As technologies like Kubernetes and machine learning become more prevalent, DevOps pros who understand these areas are in high demand. Now, you might also find opportunities to move into management or consulting roles. Many companies are just starting their DevOps journey and need experienced professionals to guide them. There's also a growing need for DevOps in non-traditional tech sectors. Finance, healthcare, and even government agencies are adopting DevOps practices, opening up new frontiers for career growth. Lastly, sharing your knowledge through teaching, writing, or creating online courses can also be a rewarding career path. So, the key to growth in DevOps is to never stop learning. This field is always evolving, and the most successful DevOps pros are those who evolve with it. So there you have it, folks. Whether you are a seasoned IT pro looking for a change or a newbie trying to break into tech, DevOps offers an exciting and rewarding career path. Remember, in DevOps, the only constant is change. So buckle up and enjoy the ride.
So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same of the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and codebase, we use tools like Git and Gira. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen, because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. when you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you'd put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers. So the 5 key takeaways here. So with a virtual machine, you're able to create a virtualized environment to run an application on an operating system. With Docker, it allows you to focus on just running the application and doing it consistently. It improves the ability for teams to be able to share environments that are consistent from team to team. It's highly productive and it's really quick and easy to configure. The architecture of Docker is really primarily built out of 4 components, of which the one that you'll use the most is the client-server environment, where as a developer you have a client application running on your local machine, and then you connect with a server environment where you're getting the latest information about that container that you're building a solution for. And then finally, what we see with the workflow improvements with Docker is that the goal is to be able to be more efficient, to be able to be more consistent with your development environments, and be able to push out those environments, whether it goes to a test person, to a business analyst, or anybody else on your DevOps team, so they have a consistent environment that looks and acts exactly like your production environment and can be eventually pushed out to a production environment using tools such as Puppet or Chef, so you're creating a consistent operations environment.
Hello everyone and welcome to this hands-on tutorial on Docker Compose. In this video, we will be working with 2 primary components. A front end built with HTML, CSS and JavaScript, and a back end powered by Node.js. Docker Compose in this scenario will allow us to seamlessly manage these components and run them in isolated containers, while simplifying the orchestration between the services. In this video, we will explore how to set up a basic front-end and back-end architecture, use Docker Compose to run both services in separate containers, define custom networks so that front-end can communicate with the back-end. So guys, let's get started. So guys, let's start with Docker Compose. So go on the Google and type Docker Compose. So you can see the first link all over here. This is the guide to the official documentation. Just click on this, and here we will be navigated to the Docker Compose official documentation. Now, what is Docker Compose, guys? Basically, Docker Compose is a tool for defining and running multi-container applications. So, multi-container in this sense can be your front end or a back-end service. Okay. With Docker Compose, you can use a YAML file, typically which is named as dockercompose.yml, to define multiple services, their dependencies, networks, and volumes in a single configuration file. This allows you to spin up multiple interconnected Docker containers with one simple command, making it ideal for environments where you have complex setups, such as microservices or multi-tier applications like web server, database, cache. So if I talk about multiple container, in this scenario, it can be such as we have these 2 files, which is a backend file and a front-end file. Okay, so this is a sample setup which I have created for you. We are going to learn about it. Now, as you can see all over here, so in our backend file, we'll be having a node project. Okay, so here are our node modules. We'll have a Docker file and a main file called server.js. Then we will have certain dependencies installed all over here. Okay, similarly for front end, we are having a simple index.html file, script.js, then CSS, okay, then the corresponding Docker file. So as I have told you earlier, that Docker Compose helps us to spin multiple interconnected Docker containers. So here you have one container and here you have one container. Now the Compose is going to run these 2 containers. So in this scenario, what I was telling. But our question arises all over here, okay? So why do we use basically Docker Compose? So one of the most important reasons what I found out is that first, you have an easier multi-container management. With Compose, you don't need to manually start and link multiple Docker containers. Compose handles it for you. Then you have the declarative configuration. The entire stack or services, networks, volumes, which are very main concepts of Docker Compose, is declared in single dockercompose.yml file. Then you get the environment consistency. You can ensure that development, testing, and production environments are consistent by using the same configuration. And finally, you get simplified commands, which means that you can start, stop, and manage complex application with just few commands. Now, there are certain key concepts. So if I talk about certain key concepts all over here, so our first concept is services. Okay. So basically services are different containers that make up your application. For example, in this scenario, we have a backend service and a front-end service. It can also be a web service, database service, and cache service. Now, the second most important concept that we have all over here is network. So if I talk about networks, guys, so networks in Docker Compose allows you to define how services are networked together. By default, Docker Compose will set up a bridge network so that your services can communicate with each other using their service names instead of IP addresses. And the third thing that we have all over here is volumes. So if I talk about volume, you can define persistent storage volumes in your Docker Compose.yml file. This is useful for databases or other services that need to persist data across container when your Docker container starts. So these are the certain important concepts, services, networks, and volume, which we'll be seeing in our Docker Compose file. Now, let us set up our workflow. Before that, I want you to have installed Docker Compose on your system. So if you have not installed Docker Compose, go all over here, install. Okay. Suppose you have a Linux system, just click on it. If you have a Mac, then you can click on it. I'm using Windows, so I'll click on this. So now you can install Docker Desktop. So I'm using x86-64 processor, so I'll click all over here. And for the same thing, it requires a WSL, okay? So you can download this also if you don't have in your system. So guys, you can install Docker Desktop on Windows very easily. The first process you can do all over here. While installing, you can just click all over here and it is going to install your Docker Desktop. So I will not do it since I already have it, or otherwise you can do it from the command line. So you can see all over here that on your terminal, you can write Docker Desktop installer exe install, then start process, and then you can copy this code. Very easy process, guys. Once you have installed your Docker Desktop, then you can start creating Docker file and Docker Compose file. But always make sure when you are running your script, your Docker engine should be running. Now let us discuss about basic Docker workflow. Okay, so you need to define, first of all, your environment with Docker Compose.yml file. So the first thing is define your apps environment, the Docker Compose.yml file. Okay, so this file will describe the services that need to be started again. Example, your front-end service, back-end service, and a database. The Docker images to use or any specific configuration for the services like ports, environment variables, or volume. So these things you have to define in your Docker Compose file. What will be your environment of your app? Now, the second step would be run Docker Compose up to start the services. So basically this command reads the Docker Compose.yml file and spins up all the services as containers, sets up the network, and ensures that they can communicate with each other. And third would be run Docker Compose down to stop and clean up your process. So this is a very basic workflow for the Docker Compose. I hope so you would have got some brief idea regarding this. Now, so let us understand the architecture of our project. So it's a very basic project, guys. In this, we have a backend folder in which I have a server.js. Okay. So if I open this file, so I'm using Express all over here to create something. Suppose what I'm going to do all over here, we will be creating a dashboard, or not a simple dashboard, a simple label where we'll be writing our name. Okay. So here you can see all over here, the port we are using is 4000. Rest, don't focus on these codes, what I have written. you can just ignore this because in this video, we'll be focusing mainly on Docker files. Now, you can see also one thing that we have the package.json. So type cd backend. And after that, just type npmi. So it is going to install all these dependencies. I will share this code all over here with you, the GitHub link. You can copy the repo. Now we have done this. So after this, we will be writing our Docker Compose file. So all over here, you can see the first thing that I'm typing all over here is use node, okay, version 22.3.0. Because if I go to the terminal, okay, first I will cross check what kind of node version I'm using. So just type all over here node. And you can see all over here, it shows 22.3.0. So this is our node version. So what is the significance of this line? Basically, this line sets up the base image for the Docker container. So node 22.3.0 refers to the official Node.js image of version 22.3.0 from the Docker Hub, where it downloads all these node packages. And also, Node Package Manager or NPM will be included in this. Now, the second thing, workdir/app. So basically, this line is setting up the working directory inside our container. So /app is our working directory. Docker container is a place where your application files will be copied. So here in this container, all your application files will be copied in this directory called /app. And then there is a copy. So copy package.json and run npm install. So you can see all over here, we have a package.json file. So all of the dependencies which are present all over here, okay, will be downloaded by Docker. Now copy the backend code. So I have added two dots, copy ... What is the significance of these two things? This command copies all the files from the host machine to the current directory, which is /app. Okay. Now the first dot refers to the current directory, okay, which is on your host machine. And the second directory refers to the destination directory inside the container, which is /app. And finally, we are exporting our port, which is expose 3000. Okay. Now we are running it on cmd node server.js. Okay. So this is our official port that we are using. I hope so you have got a bit idea regarding the backend file. Now let us go to the front end file. So we have three files all over here. So this is our index.html. Okay. This is our script.js where I have written certain script, front end script basically, and here is our CSS file. So don't worry about all these files. You can copy from the link which I'll be sharing in the description box. Now the important file that we have to focus on is this. So if I go all over here, so the same thing from node 22.3.0. So I'm installing node version of this, okay, from Docker Hub. Then I'm creating a working directory all over here. So this will be our working directory where all the code will be copied. Now similarly, the two dots are here. So I have explained you earlier. This is for the host machine. The address from all the codes will be copied to the destination, which is /app directory. Now here, what I'm doing, guys, I am running run npm install g http server. So what is http server? So basically this will install the http server package globally. So here that's why g flag is given, okay, inside the Docker container. So http server is a simple lightweight http server for serving static files. And here G is installing it globally so that it can be accessible from anywhere within the container. This is necessary because we are using the HTTP server to serve the HTML, CSS and JavaScript file. Then I'm exposing this to port 3001. And finally, I'm serving our CMD HTTP server. Then there is a comma, okay, then P, then 3001. So this basically specifies the default command to run when the container starts. So this will run the HTTP server, okay, on the port 3001, and the P option will allow you to specify which port the server will use. So this was all about the Docker file for the backend. Now we have successfully created a Docker file for our backend and for our frontend. Now let us proceed to the Docker Compose.yml file. You can see all over here, we have the version, which is 3, okay. Version 3 is specifying the version of Docker Compose file format being used. In this case, the version is 3, which is widely supported and includes the feature like networking and volume. Each Docker Compose version offers different features and syntax. Version 3 is compatible with Docker Swarm mode and also provides a better support for services and scaling. Next, you see the services block, which defines the individual container or services that Docker Compose will create and run. In this file, there are two services, the front end and the back end. And these services are containers that will run in isolated environments but can communicate through Docker network. So you can see the build is front end, ports we are using 3001. It is depending on the back end, and network is app network. Okay, so they will be communicating on app network. Similarly, for backend service, the build is backend, port is 4000. Okay, network is app network. Okay, driver is bridge. Pretty much fine. Now, finally, we have the network section. So in the networks, it defines a custom Docker network that will allow the services to communicate with each other. Docker automatically creates default network for services if none is specified. But here we have the custom network, which is app network. Now, what is driver bridge? This is a network type, which is a kind of a bridge network. This is a default network driver for Docker and provides communication between containers within the same network. Now, how these services will be interacting? So the front-end service, which will serve the static file, the HTML, CSS, and JavaScript on the port 3001. Okay. Now, on the backend service, it is most likely to run on port 4000. Okay. So that is one thing that we have built all over here. And this scenario, suppose we are building a typical application. So the front end will be hosted on 3001 and the backend will be hosted on 4000. Now let us build our Docker Compose file. Now, in order to run this application, what you have to do, guys, go to your root folder, which is demo, okay, and type Docker Compose build. Now, after this, what you have to do, guys, just right click all over here and you can see it will start building our application. So it has started building our backend file. Okay, so you can see it has started running. Now it is going to create a container demo backend 1 and demo front end 1. So you can see our container is created. Now it is starting the HTTP server. Okay, now the version we are using, okay, the version we are using is 14.1.1. The course is disabled all over here. This is security protocol. There are a lot of other options that is available. So you can see the backend server is running on port 4000 and still is on the process of creating. Now, if we navigate to given port, which is 127.3.0, so which I have already opened. So now let's right click all over here. So you can see our application is completely running on this port. Very basic application. So just click your name, something like say Sham, and right click all over here. So it's a basic application and all the data will be stored on the server. Okay. So the main agenda of this project was how we created two services, which was front-end service and the back-end service. And finally, we merged the both services with the help of Docker Compose file. So two separate Docker containers, and with the help of Docker Compose file, we are able to run this. So this was a very basic introduction to Docker Compose. I hope so. You would have got a brief idea regarding what Docker Compose does and why it is so much popular tool in today's software development methodology. Now, every job in today's scenario requires you to understand the Docker, Kubernetes, and all these important DevOps tools.
Hello, and in this video, we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it. And you should be able to look and see whether or not you can add your own company to this list.
So what is Docker? Docker is a tool which is used to automate the deployment of applications in lightweight containers. So when I say containers, I mean a software package that consists of all the dependencies required to run the particular application. And when you deploy containers, you're basically providing the capability for the application to run in any kind of environment. So Dockers have multiple features, some of which are that multiple containers can run on the same hardware. It has very high productivity when compared to virtual machines. It maintains isolated applications and has a very quick and easy configuration process. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt-get install Docker. Now, as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install docker. So snap install docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we'll pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state. And with that, we come to an end of our Docker installation.
Now, Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands, we can do the installation. But in the case of Windows, you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows String particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the Edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the Edge, right? So you also have the comparison that what is the difference between these 2 versions, right? So the particular Edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the Edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more, and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory to the downloads and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on okay. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part.
So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service. And it does this by running each container in isolation, but allowing the containers to interact with each other. As was stated earlier on, you would actually write the Compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you'd use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the, if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build-t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already. And we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker. And actually, we don't want to do image. We want to select pull. And then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to head and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded. So we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded, but we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 colon 80 colon 80, and then we'll put in MySQL colon latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker ps to list all the running containers. And what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a, and yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago. But it's in the exited mode, so what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run dash it dash dash name, and we can name it SL SQL MySQL / bin / bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images. Here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that. And it's going to, we paste that. It won't be able to actually run correctly because the image is active. So what we have to do now is stop the image and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run dash dit dash dash name white, that's going to be the name of this HTTP service, dash p 8080:80 dash v, open quotes, $pwd, close quotes, colon, /usr /local /apache2 /htdocs /httpd semicolon 2.4. We'll run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and the So we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft .NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure, and you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then typically in your traditional environment then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software but probably doesn't have all the development software, and certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80 80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run dash it dash dash name my so this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment, and we'll put in the image name, which is Ubuntu, and dash bin dash bash, and it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state, it's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exit state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container.
If you are looking to get certified in DevOps and become a Docker expert, have a look at postgraduate program in DevOps by Simplilearn. So hurry up and enroll now.
Let's dig into what a Docker swarm is. So a Docker swarm is essentially a tool that allows you to very easily create and schedule multiple Docker nodes. So really 2 or more Docker nodes. And you can have quite a large number of Docker nodes in a single swarm. Each node itself is actually a Docker daemon, and that daemon is able to then interact with the Docker API and have all the benefits of being a full Docker environment. One of the other advantages you have is that each Docker container within the swarm can then be deployed and managed but as a node in that entire clustered environment. So what we have here is a breakdown of the 5 key elements within a Docker environment. You have the Docker container, you have the daemon, the Docker images, and the Docker client and Docker registry. So the Docker daemon itself is what does all the work interacting with the actual host operating system to be able to manage the Docker containers. So if we look here we have set up an environment where we have 3 Docker containers being run with Docker. And what we want to be able to do is be able to interact with the environment, because what would happen if we actually have something change in our environment? So if we have the environment set up as a Docker swarm and one of our containers fails, what we're able to do is use the swarm to be able to correct that failure. So the Docker Swarm Manager is able to come in and reschedule containers. And as you would imagine, the actual Swarm node has full backups and full redundancy for any kind of failures that would happen. And we would do all of this work through command line interface. So let's go through some of the features that you have within the actual Docker Swarm itself. So a key feature for Docker Swarm is that it is fully decentralized, which means that it makes it very easy for teams to be able to access and manage the environment. As you would expect as well, is that the communication that happens between the manager and client nodes within the swarm is highly secure. And of course, this is really just a fundamental that you should have for any kind of solution, but it is good to know that Docker Swarm has that built in. There is also auto load balancing within your environment, and you can actually script that into how you write out and structure your swarm environment. And that load balancing then also allows you to then convert that swarm environment into a highly scalable infrastructure. And then rollback task allows you to be able to roll back environments to previous safe environments. So if, say, something does get pushed out and something breaks, you're able to immediately roll back into a safe environment. So each of the containers are pushed out and are controlled using services, and they actually happen to be REST services, which make it very easy for you to be able to integrate within your environment. And each of the different services contains a group of containers of the same image. Now, by having this structure, it allows you to be able to scale your application appropriate to the demands on your service. So if you have a service that needs to have a significantly larger number of services for it to run, you can actually scale that appropriately, and that can be either geo or demand based. One of the requirements for setting up a Docker Swarm is you must have at least one node deployed. So the way that the architecture is set up is that you have a manager node and a client node, and there must be one of each for the entire environment to be able to work effectively. So, here we are just jumping ahead of ourselves a little bit. We have two types of nodes in a Docker Swarm. We have the manager node and we have the worker node, which is the client that does the actual execution of the tasks. The manager node, very similar to other systems that we've talked about on Simplilearn, allows you to actually control and manage the actual tasks that are being executed by the worker nodes. And the worker nodes, as you can imagine, then actually execute the instructions that the manager are sending out to it. So here we have a situation where we can illustrate what would happen with a manager node sending out commands to different worker nodes. The manager is fully aware of the status of the entire swarm environment at all times. This is because of the two-way secure communication that's going from the manager to the worker environment. The workers, as you'd expect, are accepting tasks that are being sent from the manager. So if the manager sends out a task saying that you need to be running as a MySQL environment, then the worker node will then convert to a MySQL environment. And all of these environments are scripted and controlled by you as the manager. The actual worker nodes themselves actually have a client agent, and that client will then communicate all different states of the infrastructure back to the manager, so that any time the manager node is in full control of the entire swarm. The manager is the controller of this environment, and so you always want to be able to ensure that the manager has full access to all of the work that's happening within the swarm, and this allows you as the manager to be able to control your swarm and very quickly be able to react to any changes without having to rely on manual installations of software and hardware. And as we covered earlier on, there is a REST API that uses the communication over HTTP from the manager to the worker node. It's interesting to note that it is a REST API because if you wanted to, you could actually integrate that API into custom applications and even then create automated Docker images to be created on demand from third-party solutions that you may want to create. So one of the things that's a big advantage with having a swarm is that once you've actually created the swarm, any of the services that you create can be accessed by any node of the same cluster. One of the things you do have to do, though, is you have to specify what container image that you're going to use when you're creating a new service. And you can do that either through a centralized Docker Hub environment or through your own private Docker Hub environment. One of the things that's interesting is that you can set up commands and services to be either global or replicated. A global service will allow you to run a service consistently on every node within the swarm, whereas a replicated service will only push out functionality and tasks to specific worker nodes within a swarm. So you may be asking yourself, hey, isn't a service and task the same thing? No, they're kind of not in the Docker world. And the difference is a service is a description of a task for the state, whereas the actual task is the work that needs to get done. And that's the differentiator here. So what you can do as a Docker user is you actually create services and then you can then define when you want them to start as tasks. Now, what's interesting is that when you do assign a task to a node, that same task cannot be assigned to another node. Also, what's interesting is that you can actually have multiple managers within a Docker Swarm environment. If you do, however, go down this path, you have to elect one manager to be the primary manager and the other managers to be secondary managers. In many ways, those secondary managers are really similar in concept to worker nodes in which they have the capability of a manager, but they are dependent on that single primary manager to be able to provide the right instructions and for services and tasks to the entire Swarm environment. So if we kind of recap some of these, we have a command line interface, which allows us to create and connect via APIs. And that those APIs that we connect to in our Swarm environment allows us to do orchestration via tasks and services. The task allocation allows us to allocate work to tasks via their IP address, which allows them to execute them on the work. And then the worker nodes themselves have to connect to the manager node to be able to check for when tasks come in so that they are keeping a consistent communication back and forth across the entire swarm. And then the final stage is to actually execute the tasks that have been assigned from the manager node to the worker node so that you have a successful execution of the solution you're looking to build. All right, so with that said, let's go ahead and we're going to do a demo. So we're going to go ahead and do a demo and showing how you can run Docker Swarm. For this, you'll need to have both a virtual environment running your manager and your working environment. So here we have our worker and here we have our manager. So we're just going to open up terminal window and we're going to go into the manager for terminal window. So the following command here is used to initialize Docker Swarm. We're just going to type this in. So sudo docker swarm init, and we put the IP address for the network we're connecting to. And we'll put in our password. And here we have now connected. And this is our manager node, and what we want to be able to highlight is the specific token which identifies the Docker Swarm environment. And this is our token right here. So we're going to copy that because we'll need to use that for our worker environment. So here we are in the worker environment, and we'll use the token that we just copied as a way to be able to connect to the manager and connect to the Docker Swarm environment. And so sudo, we'll paste in the Docker Swarm and we'll join that. And now here we shows that we have joined the Swarm environment as a worker. And now that we're in the manager, we can actually show that we actually have that worker in the environment. So there's docker node ls to list out all of the items in that environment. Sorry, we actually did that in the wrong area. So we're on the right, sudo docker node ls to list out all the nodes in the swarm. And there you are. You see we've actually connected the worker to the manager node, and both are active, and the manager is the leader and the worker VirtualBox is in the swarm. Okay, we're going to go ahead and create a new service. So Docker Swarm create, and we're going to just change the name to Hello World for the new service, and we're going to use the Alpine image from docker.com. Takes just a moment for it to run. There we go. And there we go. Services converged. So what we have now is a new service that has been created. Let's go ahead and we'll list out the services. And here we have our new Hello World service. And we go ahead and check the Docker containers, and we're going to do Docker PS, and here's our Alpine. It's running the latest image, and that's the Docker container ID. And we can see that it was just updated. And so what we're going to do is use the same command in the worker node and make sure everything is working over there. So go over to our worker, paste that in. So what we see here is there is no image or container created because it's not in the worker node. It would be in the manager node. So we can go ahead and create the new service. And we're going to make the mode global, and that way the service is available across all of the swarm. So we're just going to execute that work. Takes a moment. And there we are. Done. Work has been completed. And we have the two different IDs, which shows the two different services running. And if we go back to the worker mode and we run sudo docker ps again, and there we are. Now we see that we have the Hello World new virtual environment has been added with the image of Alpine. And we also have the new token ID for that. If we want to kill a node from the swarm, we can use the following command, which is sudo docker swarm leave -- force. And that will force the node to leave the swarm.
So one of the questions that will come up though is, what if you want to use 2 containers in a single service? And an example of this might be like a web server that is using a database, but the database may be in one container and the web server may be in another container, which is very typical for your own web and database infrastructure. So very similar scenario, but how would you do this with Docker? So by using just Docker itself, it's actually very difficult to do this. You can do it, but it's just very time consuming and just not a very good use of your productivity. But with Docker Compose, you can actually do the whole process quite quickly and easily, and hence the reason why we have Docker Compose, to allow you to have 2 or more Docker containers running in the same environment, being able to communicate as if they were running in a production environment. So let's dig into what Docker Compose is. So let's consider a scenario that you'd have today. So Myntra is a fashion website similar to Amazon, and you would go to Myntra with your web browser, and on that website you would go through a number of activities such as logging into your account, browsing a catalog, you'd have your checkout application server, and you go through the typical process of building out an application. Behind each of these services are different products, such as you'd have an account database, you'd have a product database, different checkout processes, and these would all be run behind the scenes. And each of these can be considered a microservice. So the more microservices you build into your environment, the more complexity you're adding, and the more of value it would be to have each of these services in their own container. But as a developer, you want to be able to jump from one container to another container, so your login account can then be passed onto your product catalog and then be able to move through the whole process. So the environment that you would see today would be more like what we're showing right now, where you'd have your server and your database, and you may have a server running on Apache Tomcat or SQL Server. You'd have different databases, and you'd want to be able to have each of those in their own containerized environment. So the way that Docker Compose runs is that it works as a single service. So you have the Docker Compose running multiple containers, but the perception is of a single service running. The thing that's great though is that each of those containers will run in isolation, but they can interact with each other. So unlike a normal Docker environment where you have multiple Docker images running completely in isolation of each other, these are images that will run in isolation but can interact with each other. The Docker Compose files are very easy to write. They're all written with a scripting language called YAML, and YAML is an XML-based language. It actually stands for yet another markup language, but it's an XML-based language and it's very easy to use. The great thing about learning YAML is that a lot of open source tools in the DevOps environment use YAML as the scripting language. And then finally, in Docker Compose, as a user, you can actually go in and trigger all your services within the containers to start with a single command. As you can imagine, this dramatically reduces the amount of work that you as a developer have to do. So let's take an example of if you're running a container, one with a Nginx server and one with a Redis database. You can create a YAML Docker Compose file that actually has the instructions on the containers needed to build out both environments. And then you can run each of those environments separately, but have them connected as a single service. So the benefits of Docker Compose is that you have a single host deployment environment. You can run this all on one piece of hardware. You can have a quick and easy configuration using YAML scripts. The productivity that you get as a developer significantly increases because you're not having to have time wasted trying to configure just traditional Docker containers by themselves. You now have a way of being able to interact with those containers. And then finally, security is at the center of all of these containers. So each of those containers are completely isolated from each other, and they are controlled with the same level of security that you'd have with a traditional Docker image. But there is a question here around Docker Compose. Isn't it similar in concept to Docker Swarm? Because at a high level, it kind of seems like both do the same thing. And the answer is, well, actually, no, they're different. There are similarities, but there are also differences. And particularly for a developer, these differences will really start coming out in scale as you start working on your solutions. So let's look at Docker Compose. So Docker Compose will allow you to create multiple containers on a single host. And that's the important part, having a single host, which is maybe your development PC. With Docker Swarm, it also allows you to create multiple containers. However, you have to manage those multiple containers on multiple hosts, which makes a lot of sense if you're running an operations environment, but not so much if you're doing a development environment. And Docker Compose is scripted with YAML, which is very easy for you to be able to control your scripts. Docker Swarm doesn't have a scripting technology like YAML, so it's a little bit harder to work with. So what we have here is just some basic commands that allow you to get up and started working with Docker Compose. In our next demo, we're actually going to take you through how to use all of those commands. So we're going to go ahead and do a demo on how to use Docker Compose. The first thing you want to do is check that you have Docker installed. So what we're going to do is we're going to open up the command window and we're going to type in Docker. You'll be able to see now that we have Docker installed. If you don't have Docker installed, go ahead and install Docker. You can go to Google search to install Docker and they'll give you the instructions for that. We also have videos that we've already done. If once you have Docker installed, then you want to do a Google search on Docker Compose or go to the docker.com website and select for the Compose section and look for the install Docker Compose instructions. So we already have another tab which has the instructions already installed. You'll see on the left hand side there are a number of Docker tools. You want to expand the Docker Compose section, select install Compose, and then on the right hand side you'll have different install options for Mac, Windows and Linux. If you're installing on those platforms, make sure that you're copying the correct command lines. There's a couple of command lines you want to copy. Copy the first one over and we paste that in. And it's going to go ahead and download all of the files for Compose. It takes a while, but we have to get another file. So while it's downloading, we'll go get the other command line. Just go back and grab it real quick. It was a little fast there, but we'll copy that over. There was a second command instruction and post that command. Yep, there's the command right there. And that will apply the appropriate binary. And once you've done that, you can actually go ahead and validate that you have the correct version of Docker Compose installed. And for that, you want to write the command docker-compose space -- version. And that will then give you a version build. Once you know that you have a version build, that means that you have everything installed correctly on your machine. So you can see here that we have a version number, which means we have everything installed. You might see a different version number depending on how old the video is when you're watching it, but we're using very content at the moment. And just go ahead and clear the screen. And now what we're going to do is create a folder where we're actually going to install the YAML file that will have the instructions for our Docker Compose environment. So we're moving the cursor to the desktop, and on the desktop we're going to create a new folder and using the mkdir command, and we'll call this one Docker Compose F for file. And then we'll move the cursor into that new folder by using cd command. And now we are in the folder called Docker Compose F. And you can go look at your desktop and you'll see it's there. And now you want to select #touch docker-compose.yml, and that will actually create the new YAML file for you. And you can use the ls list command, ls docker-compose.yaml, and that'll allow you actually now to step in and edit that file. So let's go ahead and hit return, and that'll allow us to go in and edit the file. So now I'm in the editor and I'm going to write some instructions. So I'm going to put a couple of mistakes in these instructions so we can see how Docker Compose catches those mistakes. But most of this is going to be fairly correct, so you can just type this out. So we're going to start with services : then we'll do web : and then we'll create image colon, and we'll do Nginx, and then we'll do a database colon, and we'll call the image Redis. And so what you can see, because we have two reference images, we're actually calling two different images, two different containers that will be created by Docker Hub. So what we're going to do is where we can actually show you how that's pulling in. You can go to Docker Hub, and you can actually see the references to the images that we've just created. So go to Docker Hub, which is hub.docker.com, and you'll see that Nginx, Redis, those are the default names for the images. So you could do other images like HTTP for Apache web server if you wanted to. There are a lot of images in Docker Hub, so certainly have a lot of fun building tools from that environment. So we're going to save those files in the Docker image, and we're just going to do :WQ to exit this screen, save the text. Let's go and run our YAML file, and you'll see the two different error messages that will come up. So we're going to do cat docker-compose.yml, and here we have a display of the text that we just wrote. And now let's go check the validity of the file that we just created. So we'll do docker-compose config, and we should get an error message. And there we are, error message. And the reason why we have an error message is because the spacing is not correct in the YAML file itself. So let's go to the actual YAML file that we created. Let's go through, and we're going to use just the file finder, and you'll actually open up the YAML file in your text editor, your favorite text editor. And here we have the code that created it. And let's use the correct spacing so that everything is spaced out appropriately in the image. And so this is the spacing that you'd expect to see, a line between surfaces and the first image, and the first image is a tab in, and then it references what the image is. And let's go ahead and clear the screen, and we'll see whether or not we've got that all correct. Let's clear the screen, and we're going to check that everything is running correctly. And we're still getting an error message, and the reason why we're getting another error is that there's still a config error in the actual YAML file. So one of the things you have to do when you're creating a YAML file for Docker Compose is you actually have to have the appropriate version number in there. So what we have to do is we have to go and find which is the appropriate version. And there are three major versions, 1, 2, and 3, depending on the age of Docker that you have installed on your computer. So if you have the very latest version of Docker, 18 and newer, you would put 3.7 as the version number. And what we're going to do is we're going to just check on the version that we have installed. And so we'll just clear the screen, and then we'll just do Docker version. And what we have is our version of Docker is 17.12. Now this is the version of Docker, not Docker Compose. It's your main Docker environment. And so if we go back to our web browser, we'll actually see that version 17 should align with version number 3.5. Yep, there we are, version 3.5. So what we want to do is go back into our YAML file. And the very first line that we want to put in above the services is the version number. And that version number we're going to put in is 3.5. So we type in version, and we put colon, and then version number is in quotes, and you save that. And now what we can actually do is we can actually go ahead and use the single line instruction to run both of these two images that we've created, because everything is configured correctly. But with just one note, you'll see that the version number is actually at the bottom of the list, and that's just the way that Docker Compose works. It pulls out the services and the images that you'd create, and then puts the version number at the bottom of the list. So in the presentation, we talked about how you can use one line to trigger two or more images. And so to do that, we're going to do sudo docker-compose up-d. And it's going to create the two environments. We have the web environment and the database environment. And let's use sudo docker ps to actually list out all the processes that are running right now. And there we are. We actually see all of the images that are running. We have the names, the commands, the images, and everything's up and running. And if we want to close both of those images, we can actually use a single line of command as well. And that command will be sudo docker-compose down. And that closes both of the images. And we can see that all the databases and the web services images have been closed, and sudo docker ps will actually list that there is nothing running. And that's how to use Docker Compose.
So we are going to talk about what is a Docker, what is a Docker file, what is the syntax of Docker file, and how to build a custom Docker image with the help of Docker file. And in the end, we are going to see a particular demo related to the Docker files over here. Now let's talk about what is a Docker. Now Docker is a configuration management tool which we are pretty much using to prepare the automation of the deployment of the software of the applications. Now in this case we make use of the Docker containers using which we can host our applications, and within these Docker containers we are typically hosting both the application source code and the dependencies all together. So both the things are getting packaged all together into a single unit called Docker containers and getting hosted onto the server. These containers are very efficient in work because they are not taking that much utilization and resources, and at the same time they can be shared across different environments also. So the same container can be easily deployed across different environments as such. Now it helps us to maintain the isolated application. It helps in having a high productivity there, and it also helps us to resolve all the problems which is related to the dependencies for your software, because we are packaging up both the source code and the dependencies all together in the single unit, in the single entity, and that's where you will be able to get a particular final solution called as a Docker container over here. So Docker container is a complete package using which you can have like both the applications and the dependencies bundle up together into a single entity, and that's where we call it as a Docker container. Now what exactly is an Docker that let's see a particular difference between the virtual machine and the Docker here. Now if you see on the left hand side we have the host operating system which is available there. Let's say I have a laptop. In this one we have a Windows 10. Now we have a hypervisor on top of that. Now hypervisor is a software which is used to manage the virtual machines. It's a software which is available there which takes up all the requests from the virtual machines, process it, and then give the response back. So hypervisor acts like a medium between the virtual machine and the host operating system resources. So it's going to give that a particular virtual environment to the virtual machines. And then we have a virtual machines where in fact a guest operating system is there, then application binaries, then the application is hosted. So this guest operating system actually takes up a lot of utilization, and this was the old mechanism where we used to follow this mechanism for hosting our applications. So all the applications are pretty much getting deployed in the same manner on the form of the virtual machines here, right? Now if you talk about the new method which we are talking about right now is in Docker. So here we have host operating system, but instead of hypervisor we have now the Docker engine which is available there. Now this Docker engine is something which is making sure working in the same way that how the hypervisor is behaving, but it's much lighter as compared to the hypervisor. So Docker is very lightweight as compared to the hypervisor here. And here we don't have the concept of the heavy duty guest operating system over here. So the guest operating systems which we are using in case of Docker containers are very small in size. The size of guest operating systems is in GBs in case of virtual machine, but in case of Docker containers it's pretty much available in the MB size which is there. So the size of the guest operating system in case of the virtual machine is very small as compared to the virtual machine. And that's the biggest benefit, because again it will help the containers to have a low utilization, low consumptions, and that improves the overall performance of the overall mechanisms, and how exactly the new method of application deployment really helps us to go for a particular advanced mechanism. So that brings on a very good and the efficient way of doing the deployment of the applications. Now let's talk about what exactly is in Dockerfile here. Now Dockerfile is a concept which is being used as a build script. So it's being used so that we can have a build script there. So this will definitely helps to see that how we can go for a build of a Docker image, a custom Docker image. Now when we are using the Dockerfile concept, so it really helps to prepare a kind of Docker image. So docker image is the end result when you are going for the mechanism, when you're going for the Dockerfile build up here. So Dockerfile is a build script which is available for preparing the custom Docker containers, because not every Docker image is available on Docker Hub. So some containers you have to use, some images you have to use to work on that part. Now Dockerfile is a very simple, straightforward text file which is available there, and it's basically used to build up custom Docker images. So Dockerfile is basically used to prepare so when you're running the Docker build, so it's actually going to build up a particular custom Docker image, and that will be given to you. So Docker image is the whole build process which is being done. So it's a custom process which is available and being done over here in this case. So you got a Docker file, you run the Docker build command, and that's how you will be able to get a Docker image. So whatever the steps you are having in the Docker file, that will be processed one by one, and as a end result, you will be able to get a full-fledged Docker image over here in this case. Right, now let's talk about the syntax of the Docker file. So Docker file is equal to commands and the arguments. So whatever the things you want to put up, so in the Docker file you can do that, and as a part of the execution, so you will be able to get a particular end result. Now it's a kind of a mechanism where we feel that how the execution and the modifications can be done. So the comments which we are trying to do over here is that, you know, we can put up the whatever the comments we want to put in the case of Docker files, we can do that. Comments is a standard process in preparing any particular file or any kind of code, because it helps us to understand that for what reason we are preparing that particular line. Then we have the particular run statements. The commands are there, so you can see that we are running a particular command called echo. So using the run attribute, we are basically going ahead and running a particular command into our system as part of our Docker file over here. Now how to build up the Docker images using the Docker file. So you know, Docker file is just a template which is available there, where we are putting up that what are the different steps we want to follow, and these steps, when we follow one by one, step by step, so that's where we will be able to get a particular final Docker container over here. So Docker image is getting converted as a Docker container, and we are getting a Docker container as an end result. Now Docker file is being built up and stored in the version control system, and this particular Docker files, when we are processing, so it prepares a respective specific image layer over here, and this image layer is something which is benefiting us, that how the executions can be done and how we can manage on that part. So that really helps us to see that how the executions and the things can be managed, and that can help us to see that how the management of the things can be performed as such. So Dockerfile is a very good concept which is there, using which you can prepare any kind of custom Docker image, and it can be very easily handled also, and it's a fully automated mechanism. You can use it inside the CI/CD pipelines for automating the Docker images. Right, now it's Docker image is a layer by layer mechanism which is there, in which we have multiple layers. Each and every layer we are doing some specific entry, some specific task, or some, you know, changes we are trying to deploy in part of these layers. Right, so you can use the particular Docker build command to perform the executions, and you will be able to get a particular response, and output will be given back to you. So Docker file is basically helping you to see that how the executions can be done, and you will be able to get an end result over here. So the Docker image is the final result which we are getting when we are talking about the Docker file here. Right, so these are all read-only formats which is available. You cannot modify these directly, but yes, with the help of Docker file, you can do whatever the changes you want to deploy on these Docker images. Right, so this is a small example where we are using a base image as an Ubuntu 18.04. So we are using the from attribute to specify that yes, we are going to use the Ubuntu 18.04 here. Then we are pulling the file into the directory. We are transferring a particular file inside the Docker container, and then we are running a make command, and then cmd attribute is there, using which we can run the command on the runtime on the Docker container. So these are a very basic example, but eventually when we are done with this Docker image, we will be able to get a 4-layered Docker image over here, because there are 4 steps, and then hence it will be providing you a particular 4 layers in your final Docker image over here. So layer by layer these changes will be done during the build process, and in fact using the Docker history command you can see the layers, these layers information also. right? So layer 1 is Ubuntu 18.04, layer 2 is pull, and the third layer is there where we can run the make command to run this file which we have pulled on. And then finally the last one is there where we are running like using the cmd parent. So the difference between run and cmd is that cmd will run only when you run a Docker container. So run attribute will be executed during the Docker build part. So this is pretty much is a way that how we can go for the execution of a Docker file, and how we can go for the build up of a custom Docker image over here. So these are the some couple of attributes which we are using in the Docker file here. Right, now let's talk about the entry point over here. Now entry point allows you to specify a command along with the parameters, right? So let's say that you want to run a particular command over here in the Docker container. So entry point is something which you can use to refer to that. So application is the command which you're trying to run, and then you can give some arguments to that, and argument 1 is what you're trying to run over here. So entry point is very important because that eventually helps to see that how the executions can be done, and the implementations will be done over here in this case. Right, so you can see like you can run a command called echo, and then you can use the parameters also. It's not like only the commands can be used, but you can in fact use the arguments also. Now add is an attribute which is available in the Docker file, which is primarily used to transfer the files from the host machine inside the Docker image. Now let's see that you are trying to prepare your own custom Docker image. Apart from the dependencies, you need the source code also, right? So the source code needs to be transferred inside the Docker image, and for that reason we can use the add attribute. So add attribute requires a source and destination. Source will always be the path on which on the host machine the files are present, so we can give that. And destination is the folder which is available inside the particular Docker container where we want to store the files. So you can use the example over here just like this. You can use, and you can give two entries. One is the source, one is the destination. And once that is done, so you will be able to see your files being stored up in the destination directory once the final Docker image is prepared. Then we have env attribute. Now env is something which is used to set up some environment variables, which is required of course for the Docker image, for the application which is running inside the Docker image. Now environment variables are something which you can hardcode during the Docker build one, but using the when you are running, like when you're creating the Docker container, at that time also you can override these environment variables. So environment variables are very important because first during the build process you can hardcode some values, but if you really want to change them during the runtime, that also is being supported by the environment variables. So most of the times we use it as a kind of a key value pair, just like in Linux we use to set up a particular environment variable. So the key value pair is being used in case of env attribute. Maintainer is there where we can describe that what is the details about the author. These are the fields which is available in the top, so where we can give the author name and the author details like email ID and all, so that we know that who is the person who is maintaining this particular file, and we can reach out to them in case any issues are there for the Docker files here. Right, so that is what we have here in this one. So now we are going to see that how we can go for a small demo on Docker file, and we can go for the implementation of this particular Docker file and prepare a custom Docker image. So let's just wait on that part. So let's see some demo here. Now in this one we have got two examples. One is the Python, one is the Node.js one. So first of all, what we need to do is that we need to process the Python one here. So this is the sample Docker file which we have got here for the Python. Now all this one requires a Python file which is already present on the server, and we are going to transfer, we are going to copy this content over here. This is the specific Docker file content which is available to us, and all we need to do is that we need to put this content across the server so that we will be able to build our custom Docker image. So let's go back to the server. So here we have already got the Python file which is present. So we have to create a Docker file here which will have the steps related to the Docker image preparation over here. So we will be including some steps over here, that these are the different steps we want to configure, we want to set up over here in this one. So Python 3.6.4 is the version of the Python which we want to configure, and then we are going to transfer some files into /app. We are also setting up the working directory as /app, and ultimately we are running a command called pip install flask to do the installation of Flask package, and then we are starting the specific applications on that part. So I'm going to save this file, And once I save this file, so all we need to do is that we need to create a custom Docker image, right? So right now there is no image which is available over here, and it's in complete empty instance. So I'm going to run a command called docker build -t python -am dot. So docker build is the typical command, but -t is for the tag that what kind of Docker image you want to build, and then we are giving a image name, and then we are specifying dot over there. Now once we are done with that, so it will pick up all the things one by one. The basic Docker image is being pulled down, then some sequence of steps is being executed. So it's a step-by-step process which is happening over here in this case, and we are then transferring some files in the /app, and then ultimately we are going for the pip install Flask. So it's installing those packages, and at the end the final Docker image will be prepared and will be given back to us. So we will be able to get this Docker images over here. When we run that command, we will be able to find out that we got our custom Docker image also available. And as you can see that the base Docker image is also available in this one. But yes, we have added up like around 10 MB of work we have added on top of this Python base Docker image here. So that's how we are able to do the processing over here in this case, in this setup. So that's what we can do to prepare a custom environment of Python with the help of the Docker file here. Now let's see that we will be proceeding on with the Node.js to see that if the Node.js kind of setup also can be done. Now for Node.js, again, of course, we got the specific Docker file which is present, so we can process that. But let's create a new folder over there. So I'm going to create for a new Node.js folder so that we can create the work all together in this one. So I'm going to run a command called npm init, which is the command to initialize any empty project in case of Node. Now you can typically bring down some real code also, or you can say that I want to process an empty project. So you can give the configurations, you can give the custom names, but I want to process with these default name itself. So ultimately it's going to create an entries you will be able to see like all these values which we are not providing. These standards value will be picked up for the specific code, and at the end you will be able to get a package.json file created over here in this one. Now you can actually bring down the steps that how you can perform, or you can build up a custom Node.js based Docker image. Now these Docker files is giving you the capability that you can convert a full-fledged application which is deployable on the virtual machine. You can actually convert them in the format of the Docker containers over here in this one. So that's what we are going to get over here with this particular setup or these mechanisms. So let's go back to the document and see that what exactly we can copy the Docker file. So we have got this Docker file over here. So all we can do is that we can copy this one. So once we copy this specific file here, so all we can do is that we can transfer these files into the onto the server. We can convert it into the Docker file there, so that we will be able to set up the configurations and we can perform the setup around that. So Docker file is again we want to create and we want to set up on that here. So let's go back to the server. So here we want to create a Docker file, and we want to set up the files inside that. These are the different files which is being available, which is being configured over here in this one. So we are running like node server.js, which is the master file. So we are doing an expose of 8080. Then of course we have copy commands which is there, then npm install command is there, and then package.json file is also there. Now what you need to really do is that you need to go for a server.js file which is available, in which you can configure that how the setup needs to be done and how the configurations should be performed there, because that's a command, that's a script which is going to be executed within the container. So let's copy the content. Now I'm going to copy this content over here, which is like a sample Node.js code which is available. So I'm just copy this one and transfer it to the server. So server.js file we have to create here, just like we did in case of the Python, because this is the source we want to transfer inside the Docker container. So this is what we have got. Now I'm going to transfer like I want to change this port value from 5000 to 8080 because that's what it's configured in the Docker file. Of course you can configure 5000 also, depending on your requirement you can do that configurations. Now you have got these two files over here in this one. So all you need to do is that you need to run like docker build -t node.js -app and dot. So it will automatically pick up like what exactly it will go for the Node.js basic Docker image over here. So that will be processed over here in this one. So step by step it will be able to do the configurations. So first of all, it will download the basic Docker image, which is quite more in size over here in this one. Once it's downloaded onto your system, then it will proceed further with the build activity on processing the Docker file, performing the execution. So all that stuff will be performed with this help of this Docker build process over here. So it's going to process it one by one in this one. And it's going to the next step where it's transferring some of the files, like creating some working directory, transferring the files, putting up there and running the npm install command, and then ultimately it will expose the port, and then it will have the cmd attribute configured over there. So this is basically typically trying to portray that how a particular Docker image can be built up. And of course, once the build is success, you can validate it with the help of Docker images here. So this is the app Docker image which is being prepared of 911 MB, and we have got it like a final package where the runtime is also there and the code base is also available. Now you can pretty much experience it like with other actual source codes, like you can download some pre-configured Node.js websites or the source codes here, and you can try to run them onto the Docker container so that you can get the full the complete idea about that how it goes on. But right now these are the basic Docker image which you can prepare and you can build up over here in this one. So that's how it really works on for you.
If you are looking to get certified in DevOps and become a Docker expert, have a look at postgraduate program in DevOps by Simplilearn. So hurry up and enroll now.
Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own. Right, so in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a kind of a Docker build script. Just like in case of Maven we have pom.xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you are trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up, the custom Docker images are built up with the help of Docker file. So docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now how to list down all the Docker images. So docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete a Docker image, so you can go for docker image rm command to remove a Docker image completely from the Docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how Docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the run attribute, where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of Simplilearn, or whatever the name you want to give. You can give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that what for what purpose you are preparing this image. And with that, what will happen, that it will take up the values, whatever attributes you have put up into the Docker file. So that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like Docker image rm and Simplilearn. So if you do that, what will happen, that your Docker image which is related to Simplilearn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of Docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called Docker image and then rm command to remove the Docker image from your system, from your host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it out also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container, and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command. But the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as in particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container you can rename it with the new container, and that's how the particular rename of an existing container will be done with onto the Docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your Docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we are going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that, and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's in a heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps-a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a Docker container here, and the created status also shows that yes, the Docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run Jenkins, and what it will do, it will definitely help you to get the container created onto of the Jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself. That whole Jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a Control-C over here, because it says that Jenkins is up and running. So you can start using this one according to your requirement over here, right? So I'm just doing Control-C so that it can be stopped over there, right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available, but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_Jenkins. So that you can easily do with the help of docker rename command, because that will rename the Docker container name, so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now, if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container, but we do not remove it from the Docker host, because we are not going for the cleanup. Now, cleanup is very required, because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup purge of all the containers which is running on the host machine here. And that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this completely removes all the stopped containers onto the Docker host over here in this scenario. Now second one is that it creates a new image from a containers file changes. Now way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such.
What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do here is that in order to see that how we can actually remove all these top containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is in up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where for example we have got some stopped containers, but again you have to manually remove them one by one. Now if you don't want to do that stuff, if you feel that whatever the stopped containers which is available, that should be automatically removed from your system, then we have a command called docker container prune. Now for this, what we really need to do is that we need to actually stop this container, because again it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prune command over here in this one. And then I can run like docker container prune command, which will basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular docker image. Let's say that we got a docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a docker image. So all you can do is that let's again run a particular container of httpd here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes, now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit, that's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be Yes, again copying that particular container ID, and we'll say like custom image colon version 1. So we will be giving a custom name or a name of a Docker image and a tag over here in this one. So this will basically save my Docker container, which is available in this one, in the format of a particular Docker image, in a format of a Docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this whatever the changes you want to do, you can do that, and you can then put it up into the form of a Docker image, a final Docker image. And at last, if you want to remove it, so Docker rm and container ID. Now this again Docker rm will come remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So Docker ps -a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content. Right, so these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new Docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system. Right, so once the container is restarted, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one. Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will be list down all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it, now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that docker container ls is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content. And then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen, that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container and it will go in the wait status. So Docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you because the container is in stop status. So again, you have to do the restart of the container to make sure that the container is up and running. Right, so the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again, I had to restart that container over here in this one. Then again, of course, we have like docker wait, then container is there. So this will basically put the container into a block status because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output, and lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0, but in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how way you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. All you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest. So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull or MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case, it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same, if you run docker push custom image version 1. So if you do that, it will not be pushed into this particular Docker Hub. So it's going to throw an error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise, it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image, the same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen, that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does require the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations. But let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d HTTPD, like I'm just running a dummy container over here, so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you. So you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available, because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all, everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now in order to log into the Docker Hub, because before doing the Docker push you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the docker login command, where you can see that how the execution can be done. Now using the docker login command, you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that okay, the configurations is done, and we can go ahead and we can perform the execution. So docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again if you try to run Docker login, you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one, so the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the Docker volume create command. So Docker volume create command is there, using which you can create the Docker volumes, and you can pretty much do that setup. So Docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out at what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the Docker swarm commands here. Now Docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So Docker swarm is there where we can see that how the execution needs to be done. So you can go for the command called docker swarm init command. This will actually go for an initialization of a Docker swarm cluster, and once the Docker swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that, and you can execute as such over there. So docker swarm init is the command using which you can actually see that how the execution needs to be done, and how we can perform the mechanism and the changes over here. So docker swarm init hyphen advise adr address is there, which helps you to see that how the executions can be done. Now joins, you have the docker swarm join command which is available there. Now if you go for docker swarm join command, so you can have a particular host. So docker swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the docker swarm cluster. And then if you want to leave from the swarm cluster, then you can go for docker swarm leave command, and it will be simply removed from the docker swarm cluster there. Some of the couple of commands which using which we can initialize or we can remove from the docker swarm cluster here. So docker swarm is already being initialized or is being created when the moment you do the installation of docker. So docker swarm init is the command using which you can initialize a Docker container. Now once you initialize over here, so after the initialization, you got a command which you want to add it, like you want to run it onto the Docker Swarm cluster. It will act like a worker node so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like Docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your Docker Swarm cluster, so all you can do is that you can say like Docker Swarm leave -f, and you will be left out of the Docker Swarm. And now if you want to run like Docker node ls, you will not be able to get that output because it's saying that there is no particular Swarm manager which is available. So you can run Docker Swarm init, or you can run the join command to connect to that specific node, but we have already left it and nothing is available over here. So that's a way that how you can manage like what are the different Docker Swarm commands we can typically run to manage the Docker Swarm cluster. Now let's talk about the Docker Compose commands. Now Docker Compose commands is actually there using which we can create multiple containers. It's not only one container which we can go for multiple creations of the containers with the help of Docker Compose file. So Docker Compose -version is the command which we can give you the version of Docker Compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services, that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file, we can create, or we can have that particular Docker Compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification, so that you will be able to have the modifications done, and you will be able to find out a particular multiple containers gets created all together. So Docker Compose is the way that how you can do the setup. How you are going to run the Docker Compose file? So in that case, you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this, the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker Compose one. So let's try to run some commands related to Docker Compose. So docker-compose -version will let you know that what exactly version of Docker Compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker Compose file. So what we need to do is that we need to create a docker-compose.yaml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080. So, or sorry, 80 is what you can dash for the Nginx because it runs on 80 port. But now I have to run like 80 port. I want to dash that port over here in this one. So I can specify that 80 port should be available in this one. So I'm going to save this one here and I'm going to run a command called docker-compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode and it will be executed. So it will process your Docker Compose file, and since you have used a standard name called docker-compose.yaml, so it will automatically pick that Docker details and start creating the container.
As Angular is a front-end framework, we'll be using a web server called Nginx to serve the application HTML files. After this session, you will understand three things. First, what is Docker and what is it used for? You will understand the basics of Docker and what problem Docker fixes. Next, you'll learn how to write a Docker file, which you can think of as the recipe Docker uses to build your image. In this session, we'll be using a multi-stage Docker file to build our application. Third, you will learn how to use an Nginx server to serve an Angular application inside a Docker container. To follow through the examples in this session, you should have an Angular application ready and the latest version of Docker installed on your workstation. You can install Docker by following instructions on docker.com. First, let's look at what Docker is. Docker is the most popular containerization technology, and it has quickly become the de facto standard when talking about containers. Containerizing an application means packaging it and all its dependencies into a single, easily transportable and isolated container. This container will run in exactly the same fashion regardless of the computer it is run on. By providing this layer of consistency, Docker fixes the traditional "but it works on my machine" problem. Instead of distributing just our application, we're distributing a full runtime environment along with our application. While not exactly correct, it might help you to think of a Docker container as a lightweight virtual machine inside your computer. Your computer can run multiple Docker containers at the same time, stopping and starting them individually as required. A common problem in software delivery is dependency management. When one application is run on multiple development machines and multiple server environments, a small difference in the version of an external library can change the functionality of your application, making it behave differently on different environments. The beauty of Docker is that if you build your application into a container image and transfer the same container image to your colleague's computer, you can be sure that the application will function identically on both computers. This is because the container includes all dependencies for the application inside it. On the other hand, a Docker container should not have any dependencies to the host it's running on, apart from Docker itself. It's important for you to understand what images and containers are, and what's the difference between them. For the purposes of this session, you can think of a Docker image as something that holds a file system and some metadata in it. The metadata includes things like the name or tag of the image, and instructions for Docker like what command to run by default when the image is started. While the official Docker documentation is a bit vague about the meaning of names and tags, you should learn the basics of it. Every Docker image has at least one tag, and in fact, the same Docker image can have multiple tags pointing to it. Every image tag has a name part and a version part, separated by a colon. For example, the Nginx image has multiple tags representing different versions and different flavors of the image. There's a special version tag called latest, which points to the latest version of the image. All Docker commands default to using the latest version tag if no other version tag is explicitly defined. When you build an image on your local machine, or for example a build server, you can upload the image into a Docker registry. When you configure other machines to use the same Docker registry, you can download the same image to as many other machines as you like. There is an official Docker registry called the Docker Hub, and the model is the same as, for example, GitHub. You can store public images free of charge under your account, but you will need to pay to host private images. Having your images public is great for hosting open source projects, but for any commercial proprietary applications, you will most likely want to opt for hosting the images privately. If you don't want to use a third-party service, you can always run your own Docker registry. My advice is that unless you're planning on hosting a very large number of images, it's absolutely worth the cost to spend a few dollars per month on a hosted Docker registry, such as Docker Hub. Once your application ecosystem starts to build around Docker, the registry becomes a critical piece of infrastructure, and keeping it up and running can prove to be a substantial piece of work. When you build or download a Docker image to a computer and run it, it becomes a running container. If you don't tell Docker otherwise, Docker will run a pre-specified command inside the container. As far as this command is concerned, it is running inside a Linux server, and it has access to other commands and resources that are available inside the same container. You can think of a container as a sandbox, where processes running inside the container do not have access to the host system or other containers unless you explicitly specify otherwise. Note that the complete container runs around a single process created by the initial command used to start the container. If this process terminates for any reason, the container will stop. An example for our container would be the Nginx server process. When you start a container, the Nginx server process starts in it, and when the Nginx server process dies or is killed, the container will stop as well. It is possible to run multiple processes inside a single container by, for example, using an init system to spawn the processes you need, but for the purposes of this session, we'll use the concept of just a single process per container. The basic workflow with Docker is as follows. First, you will build a Docker image either on your workstation or on a continuous integration server. Second, you will push this Docker image into a Docker registry to make it available for other computers. Third, you will most likely want to run the image on a server that is accessible via the internet, so clients can access whatever server software is running inside your container. Most often this is an HTTP server, and in this session we'll be using the Nginx HTTP server. In software delivery environments that embrace continuous delivery, this workflow is often part of a fully automated pipeline. A pipeline like this can trigger from committing a piece of code into a version control system and thus automatically deploy a new version of your application into a testing or even production environment whenever you change your application code. As we discussed earlier, a container is isolated from the machine it's running on, as well as any other containers running on the same machine, unless you explicitly define connections between them. This is out of the scope of this session, but I recommend you spend some time after the session to learn about Docker networking and links between containers. In this session, we'll be running a single container that can connect to the internet through the host machine and expose a single TCP port for the Nginx server process. Building Docker images is done with Docker files. You can think of a Docker file as a text file containing a recipe to tell Docker how to build an image. The basic function of a Docker file is to be a list of instructions that incrementally manipulate an existing Docker image. The word existing here is important. While you can theoretically build a Docker image from scratch, in most use cases you will actually be using another Docker image as the base for your new image. Many frameworks and open source projects publish their own Docker images, which can be used by developers to build images on top of. In this session, we'll be using a new Docker feature called multi-stage builds. This feature is available from Docker version 17.05 forward, and it allows you to use one base image for building our application and another base image for serving it. This works brilliantly for our use case. While Angular is often used as part of the full mean stack, in this session we're only concentrating on Angular. I'm assuming you know Angular and how the Angular command line interface works, and that you have a package.json in your application directory. If you're not quite there yet, check out the excellent Getting Started guide on the Angular website. Please note that the functionality of Angular varies wildly between major versions. However, the fundamental idea behind containerizing an Angular application is the same. Our Docker file is going to have two stages. First, we'll need to build our Angular application using the ng build command. This will output the packaged application in the dist directory under our application root. In the second stage, we will place the files from the dist directory into a directory that's served by a web server, and finally run the web server itself. This is where the multi-stage build feature comes in handy. As you remember, a Docker container only has the software available which we've explicitly added into it. This means that for the ng build command to work, we need to have the Angular command line interface installed inside our Docker container. This is something we wouldn't want on our final Docker image because it's just extra weight. And on the other hand, we wouldn't want the web server inside the image we're building our application in. Because the Angular CLI is distributed as a node package, we can use the official node Docker image as the base of our first builder stage. Because Angular is a front-end framework, it doesn't come with a server-side component, other than the test server shipped with the Angular CLI. Unfortunately, this test server isn't fit to be run on production, so we'll want to use something else to serve the Angular HTML files. In this example, we will use a robust web server called Nginx to serve the Angular application. Please note you could just as well be using a server application like Apache or Lite instead. I'm not going to be diving into the specifics of configuring Nginx. Nginx does come with good documentation, but more importantly, it also comes with an official Docker image. We can use the official Nginx Docker image as the base for our Angular application image. The good thing is that this makes our Docker file very short and simple. Let's have a look. This is the Docker file, and it's divided into two stages. The way the multi-stage build works in Docker is that we're actually creating multiple Docker images with a single Docker file, but we're only keeping the last image we've defined. This allows us to build the application first and then copy the resulting build artifacts into the next Docker image. The idea behind this is that our final Docker image won't have all the build time dependencies in it, which makes the resulting image nice and small. In the first stage, we'll use the from directive to instruct Docker that we want to use the Node 8 image as our base image. We're also using the asBuilder keyword, so we'll be able to reference this stage in our second stage later. The next directive is the copy directive. This command is for copying files and directories from our local machine to the Docker image. We're giving this directive two arguments: the location of our application code directory and the target path within the Docker container. In this example, our application code sits in test app, and we want to place it in the directory test app inside the container. The next directive is workdir. This tells Docker that all following commands should be run within the specified directory, which in this example is the application directory within the container. The next directives are the run directives. As you might guess, these directives instruct Docker to run commands inside the container. First, we're running npm install to install all node packages defined in the package.json file of our application. Then we're running ng-build to package our Angular application in the dist directory. Now we'll get to the second stage, which is copying the contents of the dist directory into a directory that's served by default by Nginx. We're using the from directive again. This tells Docker to start building another image. We're defining the from image to be an image called Nginx, which is the official Nginx Docker image. This image is pre-configured to run the Nginx server and serve HTML files that are stored in a predefined directory. Next, we'll use the copy directive, but this time with the from argument. This tells Docker to not look for the source path in our workstation, but instead the previous stage in this Docker file. Essentially, we're copying the contents of the dist directory in the previous Docker image into a directory called user share nginx html inside our new image. The nginx Docker image will then serve the contents of this directory. Finally, we're using a directive called expose to tell Docker that the port 80 has a server running in this image. The port 80 is the default HTTP port, as you might know. Note that the expose directive alone isn't enough to actually expose the port when the image is run. You can merely consider this as a documentation feature, and will still need to explicitly map port 80 from the container into a port on the host machine. This enables you to connect to the mapped port on the host machine, which will then forward the connection into the container. To follow this session for your Angular application, create a file with these contents and place it in the parent directory of your application code. Remember to customize the paths in the file accordingly. Make sure the name of the file is Dockerfile written as one word with a capital D. Now that you've learned what a Docker file is and what one looks like for an Angular application, let's learn how to use it to containerize an example Angular application. For this, we'll be using the Docker command line interface. After you've installed Docker on your workstation, you can use the Docker command line interface to build and run images. To find the command line shell on a Mac, click on the Spotlight search icon on the top right corner of your screen and write terminal followed by enter. While the Docker command line provides many features, in this session we'll concentrate on two, the Docker build and the Docker run commands. First, let's navigate to the directory with our Docker file. The command we'll be using is docker build. We'll be giving the command the -t argument, which defines the tag for the image that will be built. For this, we'll be using the tag test app. The second argument for the docker build command is the build context. This is where Docker expects to find the Docker file. We'll use a single dot to denote the current directory and press enter to start building. You can see Docker runs through every directive in the Docker file as a step, outputting the directive and the output of running it. Finally, you'll see that Docker has successfully built the image and tagged it as test app latest. As you might remember from before, since we didn't define the version tag, the tag latest is used automatically. Great work! Now, let's run the image we just built. For this, we'll be using the docker run command. We'll be giving the docker run command a few arguments. First, -i and -t to denote that we want to run the image in an interactive terminal, that is, running the container attached to our current terminal session so we can see the output and interact with the process. We'll also be using the -p argument to map the port 8080 on our workstation to port 80 inside the container. As you remember, the Nginx server is listening on port 80. With this mapping, anyone connecting to port 8080 on our workstation will get forwarded to port 80 inside the container. Finally, the last argument is the tag of the image we want to run. We're using test app latest. Now that the container is running, let's use our web browser to navigate to port 8080 on our local machine. And we can see our Angular application being served. Well done! You can see that Nginx by default outputs all the requests in the standard output of the container. After you've finished testing, press Ctrl+C in your terminal to terminate the Nginx process and thus kill the container you were running. And that's how you Dockerize an Angular application. Before you go, 3 takeaways. 1. Using Docker makes it easy to ensure that your application runs consistently on different workstations and servers. Secondly, Angular is a front-end framework. Angular needs a separate web server software for serving it. Nginx is a fast and robust choice. Finally, using multi-stage Docker files enables you to streamline your build process and create slim Docker images.
Do you know, friends, that Kubernetes is also called K8 or Kube? It is an incredibly powerful platform that helps you manage and scale applications automatically. But it can feel complex and overwhelming at the same time. Many people find Kubernetes a bit tricky when they read through the documentation, especially when they are trying to understand how all the pieces fit together to manage containers. In this video, we are going to break it down for you in easy terms. We will explore 2 types of nodes in Kubernetes, the master node and the worker node. We will talk about how these nodes work together inside the cluster to manage and orchestrate your applications. So guys, without further ado, let's get started. So guys, let's start with understanding first what is pod. A pod is the smallest unit in Kubernetes. It is like a wrapper around your application. Inside a pod, there's usually 1 or more containers. Now you'll be wondering, what is a container? A container is where your actual application runs. It includes everything that the app needs to function, like code, system, libraries, and dependencies. Containers are lightweight and can be easily moved across different environments, making them very popular in modern software development. You can think container like a box that has your app and everything it needs to run. Whether you run it on your laptop or on a cloud server or inside a Kubernetes pod, the container will always behave the same way. Let me give you one example. Suppose you run an online e-commerce store. You have a front-end web app that the customers see and the back-end, the database that stores the product information and orders. In Kubernetes, you might choose to package the front-end and back-end as 2 separate containers. So you could run both the web app and the database inside the same pod. In this case, both containers, front-end and back-end, share the same resources, such as memory and network. This might be useful if they need to be closely coupled and always run together. Now, pods are basically responsible for managing resources for containers inside them, like the memory, CPU, and storage. And each pod runs on a node, and Kubernetes decides which node will run on each pod. Now, let's understand the Kubernetes architecture. So guys, as we all know that Kubernetes is an open source platform designed to automate, deploy, scale, and manage centralized application. It provides a powerful way to ensure that your applications are running efficiently and can easily scale across multiple machines, and can also recover if something goes wrong. At the heart of Kubernetes architecture, there are worker nodes and master nodes. These 2 components work together to ensure your apps are always running smoothly. In this video, we will take a closer look at each of these components and how they interact with each other. So let's understand first the worker nodes. Worker nodes are the machine, which can be either physical computers or virtual machines, where your applications actually run. Think of them as the workers for your Kubernetes cluster. They execute your app workloads, handle the tasks required them to run. Each worker node in Kubernetes runs these 3 main processes. That is container runtime, kubelet, and kubeproxy. Let's understand each one of them one by one. The first process is container runtime. The container runtime is like the engine of your worker node. It is responsible for running your applications, which are packaged into containers. Containers are basically lightweight standalone units that contain everything your app needs to run. This includes code, system libraries, and dependencies. The container runtime is a software that ensures these containers are properly managed and executed on each worker node. One of the most popular container runtime is Docker, as you can see all over here. So there are 2 instances of first, there is a my app, which can be a front end. Then you can consider this as the back end. So guys, you can consider something like this. These 2 as your 2 containers. This can be a front end, this can be a back end or database. Now there's a container runtime all over here, which can be Docker in this case. So the container runtime in this case is Docker, and it is ensuring that the container for your web app is running on the worker node. So if you have multiple applications, they will be packaged into separate containers and container runtime will manage them, making sure they are running as expected. The next process that we are going to discuss about is called kubelet. Kubelet is like a manager that oversees everything happening on a worker node. It talks to the master nodes, which are responsible for managing the entire cluster. The kubelet gets instruction from the master node detailing which application or pods needs to be run on the node. It ensures that these applications are running by managing containers inside the pods. Unlike container runtime, which is specific to managing containers, the kubelet handles the interaction between Kubernetes and the worker node. It is responsible for making sure that the right number of containers are running, that the resources like CPU, memory, and storage are allocated properly to those containers. So you can say, for example, we have the master node that sends a request to the kubelet saying run 2 containers for the web app. So one container is there for web app and one is for the database. The kubelet will check the available resources on the worker node and ensures that the containers are up and running. It also continuously monitors the health of these containers to make sure they don't crash or run into problems. If container fails, the kubelet can restart it based on the policies defined in the Kubernetes, ensuring that the application remains highly available. I hope so you would have got an idea regarding kubelet. Now let's move ahead and understand about kubeproxy. Think of kubeproxy as a traffic director for your Kubernetes cluster. In a distributed systems like Kubernetes, your applications which are running on different nodes, kubeproxy is responsible for managing network traffic and ensuring that data is routed correctly between different services and pods. When your application needs to talk with each other, in this case, kubeproxy sets up the necessary network rules and ensures that the traffic flows smoothly between different pods, services, and nodes. It manages the internal networking of the cluster and ensures that each pod has a unique IP address. Now, let's move ahead and understand about the working of master nodes. While worker nodes handle the execution of the application, master nodes are the brain of the Kubernetes system. The master node manages the overall state of the cluster and makes decisions about which application should run and where they should run. The master node constantly monitors the clusters to ensure everything is working as expected. There are 4 key components that make up the master node. The first one is API server. The API server is like the front desk of the Kubernetes control plane. It acts as an entry point for all the requests you send to the Kubernetes. Whether you are creating a new application, checking the status of your pods, or scaling your app, you communicate with the Kubernetes through the API server. The API server handles all these requests and ensures that they are passed on to the correct components within Kubernetes. For example, let's say you want to deploy a new web application in your Kubernetes cluster. You would send a request to the API server, which would receive the request. It will validate it and pass it to the appropriate components, like it can be a scheduler or a control manager. Now, let's move ahead and understand about the second component, that is the scheduler. If I talk about the scheduler, guys, the scheduler is like a smart planner for the cluster. It is responsible for deciding which worker node should run a new application. When you create a new app in Kubernetes, the scheduler looks at all the available worker nodes and determines the best node for the app to run on. Based on available resources like CPU, memory, and network, the scheduler ensures that your apps are distributed efficiently across a cluster so that no single worker node is overloaded. Now let's move ahead and understand about control manager. The control manager is like the quality control department of Kubernetes. It constantly monitors the state of cluster and ensures that everything is running as it should. If something goes wrong, like a pod crashes or a node goes offline, the control manager steps in to fix it. The control manager is responsible for ensuring that the desired state of the cluster matches the actual state. If you define that you want 3 replicas of an app running and one of them crashes, the control manager will automatically create a new replica to maintain the desired state. Now the final component is etcd, which is also called as the cluster brain. etcd is a database that stores all the data about the Kubernetes cluster. It is often referred to as brain of the cluster because it keeps track of everything, including the apps which are running, where they are running, and the overall state of the cluster. etcd is a distributed key value store meaning it can store data across multiple machines and ensure that it is highly available and fault tolerant. This is crucial for Kubernetes because the entire system relies on etcd to know how the current state of the cluster is. For example, if you want to deploy a new app, Kubernetes stores information about the app, like its configuration, location, and state in etcd. If something happens to the cluster, Kubernetes can recover the current state from etcd. Now let us look at the example of setting up a cluster. Now that we understand how worker nodes and master nodes work, let us go through a simple example of a Kubernetes cluster setup. In this, you have a basic cluster with 2 master nodes and 4 worker nodes running on it. Let us say these pods contain a web app and a database. You start by creating pods, and each pod contains one or more microservices for your web app. Then the scheduler steps in. Once you submit the request to Kubernetes through the API server, the scheduler looks at the available worker nodes and assigns both the pods to your worker nodes. Then comes the kubelet, which manages the pod. The kubelet on the worker nodes receives the instruction from the master node to run on the 2 pods. It starts a container inside each pod using Docker or another container runtime, and it ensures they are running smoothly. Then we have kubeproxy, which handles the communication. The web app pod needs to communicate with the database pod. Kubeproxy sets up the network routes and ensures that the 2 applications can exchange data securely and efficiently. Then we have control manager, which ensures the stability. If one of the pod crashes or fails to start, the controller manager detects the issue and creates new instance of the pod, ensuring that both your web app and the database stay online. Then finally, we have the etcd, which keeps up the track. All the information about the state of the cluster, including running pods, their location, their status, is stored in etcd. This ensures that the cluster can recover from any issues and always knows what is happening. So this was a simple example illustrating the cluster setup. Kubernetes is a powerful platform for managing containerized application across cluster of machines. By understanding the roles of worker nodes and master nodes, you can see how Kubernetes automates the deployment, scaling, and management of your apps.
Why exactly the Docker networking is it important? Let's talk about some scenario over here. So my application is something which totally works perfectly fine into my system and there is no issues on there. I ran it perfectly fine and I got the response. I'm able to interact, everything I'm able to do. But the same application does not works on the other person's system. Now what could be the issue? Because it's working on one machine and it's not working on another machine. Now the application does not work on another system because there is a difference in the computer systems. Maybe one system is having a different machine and another system is having a different machine, and you may be having some of the differences maybe in the term of hardware, maybe in the terms of software. So the differences are possible in 2 different machines. So how we can get a solution that we don't get this kind of problems, and once the container is prepared, it should be able to run it across different systems. So Docker networking is the ideal solution for this problem over here. With Docker networking, the application works totally fine, and it's something which can work on any system. You don't have any dependency that it will run only on a specific machine or a particular system. So what exactly is in Docker networking all about? So Docker networking enables a user to link a Docker container to as many as networks he or she requires. So you can actually connect a Docker container to a specific network. The Docker networks are used to provide complete isolation to the Docker containers. So you can have it like, okay, I want to run some couple of containers in a different network and another containers I want to run it into a different networks. So you can do that isolations, and the whole purpose of doing that isolation is so that we will be able to have a proper networking and proper executions and all that stuff. So Docker networking is a very important concept when we talk about or when we come up with the interaction or having the Docker containers isolated. So it resolves most of the problems. Okay, so you can have like multiple containers in running in same network. You can have different particular networks also there. So a specific network
have its own attributes, and then you can use those attributes to connect to that containers and to access that containers. But the whole idea is that the containers are something which is specifically running in a set of servers or in a set of platform. So whenever I'm trying to look forward to that particular container, it has to be there into a network. If you don't run it into your custom network, then whatever the default network present, it will be hosted in that network there. So how does the Docker networking actually works? So you got a Docker file. So using the Docker file, you got a custom Docker image, and from this Docker image you have to actually go there and put up like the Docker container. So you can also store this Docker image to the Docker Hub so that the same Docker image can be shared across different users, and they can also pull down their Docker image and they can have the container running in their systems. So for the collaborating the Docker image, you require the Docker Hub, and the container is the ultimate thing or object which we need to create out of the Docker image. When we go with the particular process, when the whole process goes on over there, so what happens that instead of the Docker Hub, you can use your own private repositories also. That's something which totally relies onto you, that how exactly those things works on. So a Docker file creates a Docker image using the build command. A Docker image contains all the project source code, all the dependencies. Using this Docker image, you can actually run the source code in order to get a Docker container. The moment you initialize or run an instance of Docker image, you will be able to get a Docker container. You can actually use the Docker Hub for collaborating or for sharing the Docker image. So you can store the Docker image on Docker Hub, and then different people can actually go ahead and download or pull this Docker image onto their system, and they can also run their specific containers. So what are the different advantages we get with the Docker networking? Very first one is the rapid deployment, portability, better efficiency, faster configuration, scalability, and the security over here. So these are some of the advantages which we get when we talk about the Docker networking here. Now let's talk about the container network model here. So what is the network model we are looking forward from the containers perspective? Now this is a kind of a architecture here. Now in this one, let's see that how it actually works on. Now you have a Docker engine, which is a main component which takes up all the things, and all the important components are actually integrated with each other. Now the network sandbox is the one in which you will be having your container running up and running. Now every network is having its own attributes, the particular different gateway IPs, the IP addresses, the range of IP address, the CIDR blocks, also everything can be different for two different networks. So the whole point is that you will be defining, okay, if you don't define that I want to run this particular container into a specific network, then definitely that's going to run into default network which gets created the moment you do the installation of Docker. But anyhow, any network is required for running a Docker container. So there are different network drivers which is available there. So if you feel that you want to create a network, so you have to choose a particular networking or the connectivity over there, and it really helps us to understand that how the configurations and how the different modifications and those changes can be really done here. So a lot of changes are actually going on and performing there, and this really helps us to understand that how the things are being done as such over there. So network is something which is very important from the containers perspective. So the network sandbox is an kind of a isolated sandbox that holds all the network configurations of the containers. So you will be requiring at least one Docker container network if you want to run a container in that particular sandbox. So sandbox is created when a user requests to generate an endpoint on the network. So that's where the sandbox gets created. It can have several endpoints in a network as it represents a container's network configurations like IP address, MAC address, DNS name. So every container will be having its own unique IP address, right? So that can be a particular endpoint to connect to that container, and it can have it like different endpoints and different networks. So that's always the possibilities which is available there. Now the endpoints establishes the connectivity for the container services with other services also. So the moment you work on the particular endpoints, so that can be used for having, okay, there is a service running in a container, so how you can do that. So in order to connect that, you require these endpoints so that you can establish the connectivity with the container services, whatever running inside these Docker containers. Right now, the network is something which provides the specific underlining network attributes, like the networking support to the Docker containers, because these network sandbox boxes will definitely have a requirement of the network. So how you're going to get that you will be only able to get when you go, okay, I will be looking forward for the connectivity, and I can go for the communications, and I can give the hardware, because although it's a OS level virtualization, but still you require some interaction with the hardware from the networking perspective. And then Docker engine is the base engine which is installed on the host machine, and it's actually the main component which makes sure that the Docker containers and the corresponding Docker services are always up and running. And the using the network drivers, you can actually create multiple networks onto your system, and you can have those configurations. Now, the network architecture is something which helps us to provide the connectivity among the endpoints that probably belongs to the same network, and it's something which is a kind of isolated network. So different networks can be isolated networks, and we can have the endpoints to them. So there are different ways in which we can establish the connectivity, and this is a complete network architecture which is there. So you have a network drivers, you have the networks, you have the network sandboxes in which internally the Docker containers are running, and then these network sandboxes are having their respective endpoints there to access them to establish the connectivity. Now let's talk about the network drivers. Now there are 5 type of network drivers which is available. First one is the bridge, host, none, overlay, and Mac VLAN. So these are the different particular network drivers which is available over here. First one is a bridge. It's a private default network created on the host. If you go there, if you go to the installation of a Docker, this is the default driver which gets installed onto the system, onto the host. The containers linked to this network will have an internal IP address through which they can actually communicate with each other. On the same machine also, you can establish the connectivity. You can connect to the containers using that private IP address, but outside the server you will not be able to have the communication. But internally you can connect to the containers, and containers can also interact with each other. They can also communicate with each other with this one. The Docker daemon creates the Docker 0. So if you run the IP config or if config on the system, you will be able to see a Docker 0 kind of a Ethernet bridge network which is created, using which you can see that, okay, this is the network which is created by default. It's a default installation or default configuration which automatically happens the moment you set up a Docker instance. So you don't have to go into the configurations or in the setup of there. It will be already available on that particular installation mode there. And the next one is the host one. So it's a public network. So when we go with the public network, it's actually uses the host IP address and a TCP port in order to interact with the service running inside the Docker container. So if you are looking forward that I want to reach out or I want to connect to the container, but I want to use an IP address which can be accessible from outside world, probably some other server should be able to resolve that. In that situation, the host network driver comes into the picture. So it effectively disables the network isolation between the Docker host and the Docker containers, which means that using this driver, a user can actually run multiple containers. You know, it's not possible for the user to run multiple containers on the same host because of the fact that you are using the host IP address. Now, when we were talking about the bridge connection, at that moment of time, we were getting the private IP addresses, which was totally isolated and totally unique. So there were actually, if you create using the bridge connection multiple containers, so you will see that if there are 5-3 containers, everyone will be having a different private IP address. But the moment you go for the host one, so in that situation, the IP address is not going to change. So you get some restrictions, okay, because the combination is of IP address and port. So IP address and 8080 can happen only once. It cannot happen multiple times. So that's a limitation, that you cannot run multiple containers on the same host due to this restriction. And next one is the none. So in this network driver, the Docker containers will neither have any access to the external network, or it will not be able to communicate with the other containers also. total isolation and total private containers are being done when we use this driver. So these options are usually used when you want to disable. So this is not doing nothing but disabling the total networking functionality for a specific container. That's what is happening over here. Next one is the overlay. So this one is utilized for creating an internal private network to the Docker nodes in the Docker Swarm cluster. So overlay does not comes up in case of a standalone Docker installation. The moment you go with the particular Docker Swarm cluster, at that moment of time the overlay type of network is created. So Docker Swarm is an orchestration tool, so that requires a overlay kind of driver which can help them to achieve the networking in case of cluster, because in case of Docker Swarm you have a master node, manager node, worker nodes, different machines are there. So in that situation, overlay is the main component, or is the main type of driver which is used. And then we have the MAC VLAN, so it simplifies the communication processes between the containers. This network assigns a MAC address to the Docker containers. With this MAC address, the Docker servers will route the network traffic to a router. So it's not on the basis of IP address, it's actually on the basis of MAC address. So on the specific MAC address, the Docker server will redirect the network to a specific router. Right, it's usable when a user wants to directly connect the containers to the physical network rather than the Docker host. So that's where this communication works on. So it's a direct connectivity between the host network and the Docker container. So there is no virtualization which is happening over here. So it's something which is giving a direct access to the networks, but it's definitely on the basis of MAC address on which the communication is happening. Now let's talk about the networking implementation, and we'll see that how we can go for a particular bridge network implementation there. So let's go back to the virtual machine. So I am connected to a particular system here, so I can check that if the Docker is available to me, and I can just run the Docker version. So it says that okay, the client and the server component both is available there. Now we are going to see that what are the different containers what are the different Docker containers network which is available there. So I'm going to run a command called docker network ls. Now the moment you do it, over here you will see that none, host and bridge, these are the different containers network which is available there, and you can see their network IDs, the names, the drivers. The drivers is also very important because that's what we are going to use here. So it's a very good one here. So the default one, you can see that the bridge is available, and it's a default one whenever you create any container. By default, whether you give the container attribute or not, it's something which gets created into the terms or in the basis of the container only, in the default network only. So how we can get that? We can always get that part by having the understanding that what network we are using. So I'm going to run a couple of containers or small container, and we can see that how exactly the containers can be executed and can be done over there. Right, so let's see. So I'm going to run a command docker run -d it -name alpine1 alpine image is what I am going to use, and sh. So it pulls down the alpine image. That's what it happened, and the same thing I'm going to run, but this time I'm going to run alpine2 because I want to create two containers. Right, so with this one, what will happen, that I will be having two containers available here. So I can say like docker ps, so I can see that two containers are running. One is the alpine and one is the alpine2. Right, so now what happens, that we will see that how the connectivity happens and what are the network details. So what I'm going to do is that first of all I'm going to do an inspect over there onto the bridge connectivity so that I can get the detailed information. So this is the name of the particular ones of the network. So this is the network which is available, and this is the default one. So if I scroll up, you can see that this is the name of the bridge connectivity, and even if you to run the Docker network ls, so you will be able to see that the ID also. So ID also, if you compare, so E65, that's the one which is available. Now this one is something which is using a driver called bridge, and here you can see the subnet information. Now if you scroll down, you can see that 2 containers are available here. So I did not provide any kind of network details, but definitely what happens that the 2 containers which I deployed are basically running inside this network. Okay, and you can see that the bridge name Docker 0 is the internet network which gets created, which during the installation of Docker gets configured. Now you can see that this is the IP address, this is the IP address here, this is the MAC address, and this is also a MAC address here. So the IP address, you can see this is a 3.0.3 in the last, and this is .2 over here. So you can see that the sequence is there. So Alpine 1 was having an IP .172.17.0.2, and Alpine 2 is having an incremented IP address like a different one as in 3. So you can see that these different IP addresses are there, and represents, if you want to access them, if you want to connect on them, you will be able to have the connectivity accordingly. So even if you go inside these containers, you can actually see that what exactly the connectivity you want to establish or the connectivity you want to perform here. Right, so this is the way that how the network usually works, and the networks bridge you are using over here is the bridge ones, which definitely helps us to understand that how the configurations can be done. Now, so what we are going to do over here is that we will try to see that how exactly we can go ahead and we can connect on there, and we can also see that if we are able to communicate with each other, because probably if I run like ping command over here, and I'll put the containers like 2, and I'm able to reach out. There is no problem in reaching out to these IPs because these are the private IP addresses, and I will be able to reach out to them without any problem and without any concerns. So from the current connectivity perspective, there is no problem as such, and I have a connection available over here. But let's see, we'll go back to the containers. We'll see that how exactly we can talk about, we can reach out the one container with each other. So I want to connect Alpine 1 with Alpine 2, so how we can do that? So I'm going to use like Docker Alpine 1. Okay, now I got a terminal. So what I can do is that I can go for the IP address show. So with this one, what will happen that I will be able to know the IP address. So .2 is the one which is available over here. Okay, so this is the IP address. Now I can simply do the small ping command. So I can say like ping google.com, so that will show me that if I have an internet connectivity, so that is great. So I got a connectivity with the internet over there, so I will be able to reach out any websites or any kind of that order. Now I have another IP. So .3 is, remember we were using the different IP, so I can actually do a ping also here. So ping -c5 request will put, and 3 will do here. Now we are trying to reach out to the Alpine 2 over there. So although we are connecting to the Alpine 1, but we have the connectivity with Alpine 2 also. So from Alpine 1, you can connect to the Alpine 2 containers. So that shows that since both of them are running in the same container, so they are having the automated connectivity, and you can easily reach out to them, and without any issues you can do that. And similarly, the same thing you can do it in case of Alpine 2 also. So you get it connected to the Alpine 2, and you can just follow the same thing. So you can connect it with the, if you go to the Alpine 2, you can connect to the Alpine 1 also. So if you come out, the containers will be always up and running, and you will be able to have the mechanisms there. So the whole idea about these things is that it will be basically helping you to understand that how the executions can be done and how we can perform the activities as such over here. So this is the way that how we deal with the networkings and how the containers gets created into a network, and then they can interact with each
Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problem specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing, and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the #1 container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising, because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it. And you should be able to look and see whether or not you can add your own company to this list.
Did you know the famous global researcher Gartner predicts by 2023 more than 50% of the companies will be adopting Docker containers? However, a serverless container like Docker will have a rise in the revenue from a small base of 465.8 million in the year 2020 to 944 million in the year 2024. In this video, we will be doing a side-by-side comparison of the Docker containers and the virtual machines. But before that, let's have a look at the objectives of this lesson. In this session, you will have a good understanding of what a virtual machine is and what a Docker is. Followed by that, we will have a major difference between Docker and the virtual machines. Also, we will discuss some of the key differences between Docker and virtual machines. And finally, a use case on what made BBC to use Docker. So the first one, what exactly is a virtual machine? It is an isolated computing environment that enables a person to use an operating system via a physical machine. Virtual machines provide the functionality of a physical computer. As you can see on my screen, there is a virtual machine, and this is how a typical virtual machine looks like. Now, let's look at what a Docker is. Docker is an operating system level virtualization software platform that enables software developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. And a Docker container is a lightweight software package that includes all the dependencies like frameworks, libraries, and many more, which are essentially required to execute an application. This is the architecture of Docker tool. Now, let's move on to our next main topic for the discussion, that is Docker versus virtual machine. When it comes to comparing the two, we could say the Docker containers have much more potential than virtual machines. As you can see on the left and right hand side, both the images look similar. Now, let's define the layers of virtual machine from the bottom up. Let's begin with the infrastructure. Infrastructure could be a computer system, a laptop, or a virtual private server, such as an Amazon EC2 instance, or Azure Virtual Machine, or GCP Virtual Machine instance. On the top of the infrastructure runs the operating system. An operating system is a software that manages hardware and software resources for the computer programs. On your laptop, this will be likely Windows, Mac OS, or Linux flavored operating systems such as Ubuntu. Next comes the hypervisor. A hypervisor is a firmware that builds and runs virtual machines. There are two types of hypervisors. Type 1 hypervisors are HyperKit for Mac OS, Hyper-V for Windows, and KVM for Linux operating systems. And Type 2 hypervisors are VirtualBox and VMware. Then we have the guest operating systems. Consider an example where you want to run two apps on your server in total isolation. This process would require 2 guest operating systems which will be controlled by a hypervisor. Virtual machines come with many dependencies, where each guest operating system will at least occupy 512 MB of your RAM. This is worse because each guest operating system needs its own CPU and memory resources. Eventually, this will be expensive. Then, on top of that, each guest operating system requires its own dependencies such as binaries and libraries. Since every application has different dependencies, it requires its own set of libraries. Finally, it's the application. This layer consists of the source code for the application you have built. This was all about the virtual machine on a server. Here's what the same setup looks like when you're using Docker containers. Here, you'll notice that there are a lot fewer layers. Docker doesn't require a bunch of massive guest operating systems. Let me break it down from the bottom up again. Infrastructure and host operating systems are the same as we discussed for the virtual machine. Coming into the third layer, instead of a hypervisor, Docker uses Docker Engine. Docker Engine or Docker is a client-server application that builds and executes containers using Docker components. Next, we have our dependencies. Just like on the virtual machines, here dependencies are built into a template called Docker images. As you can see on the screen, each application is still isolated and occupies less space. Now, let's have a look at the significant differences between Docker and virtual machine. Let's start with the operating system first. Docker is a container-based model where containers are software packages used for executing an application on any operating system. On the other side, virtual machine is a container-based model. It utilizes user space along with the kernel space of the operating system. A kernel space is where the core of the operating system runs and provides its services to the user. A user cannot modify this space, and user space is the portion of the system memory in which the user's processes run. Docker containers share operating system kernels with other applications and result in a higher server efficiency. Hence, Docker provides the most substantial default isolation capabilities among the other configuration tools. On the other hand, virtual machines do not share the operating system. Also, it does not provide isolation in the host kernel. In Docker, multiple workloads can run on a single operating system, but in virtual machine, each workload needs a complete operating system or a hypervisor. The next significant difference between the two is the performance. In the case of Docker, they use the same operating system without any additional software like hypervisor. In case of virtual machines, performance issues are a major problem. It can be due to the several reasons like CPU constraints, memory allocation, network latency, and many more. Running multiple virtual machines lead to an unstable performance. Docker containers can start up quickly and result in less boot-up time, whereas virtual machines do not start quickly and lead to a poor performance. Now, let's talk about the next difference, which is portability. With Docker containers, a developer can build an application and store it into a Docker image. Later, he or she can run it across any host environment. But when it comes to virtual machines, it has portability issues. Virtual machines do not have a central hub like Docker does, and it requires more memory space to store data. Docker containers are smaller than virtual machines, due to which the process of transferring files on the host file system is easier. On the other hand, dependency on the host operating system and hardware makes virtual machines less portable. While transferring files, virtual machines should have a copy of the operating system and its dependencies, due to which image size is increased and becomes a tedious process to share data. The boot-up time between the both is very different. The application in Docker containers start without any delay since the operating system is already up and running. On the other hand, virtual machines take much longer time than it takes for a container to run applications. These containers were basically designed to save time in the deployment process of an application, whereas in virtual machines, to deploy a single application, virtual machine needs to start an entire operating system, which would result in a full boot process. So those were the major differences between Docker and a virtual machine. Now let's discuss the minor differences between them. Docker is not always in a running state. It stops when the stop command is executed, whereas the virtual machines are always running in the background, which will result in huge RAM consumption. Talking about snapshots. Docker has a lot of snapshots. A snapshot is an image that you can upload on a private repository to access it on another host. But virtual machines do not consist of any snapshots. In Docker, images can be version controlled just like Git. They have local registry called Docker Hub where users store and distribute container images. On the other hand, virtual machine does not have a central hub. They are not version controlled. Docker can run multiple containers on a system. Users can connect multiple containers using user-defined networks and shared volumes. Multiple containers can be accessed on the same machine and share the operating system kernel with other containers. Each container is isolated in user space. Also, Docker containers occupy less space than virtual machines and start instantly. Virtual machine can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Multiple containers can be started at a time on the Docker engine. The isolation environment allows a user to run and deploy several containers simultaneously on a given host. Virtual machines can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Now that I have told you the differences between Docker containers and virtual machines, let me show you a real-life case study of how BCC uses Docker. BCC News is a British news channel over 500 developers working across the globe. BCC News delivers broadcasts in almost 30 different languages and with over 80,000 daily news in English alone. The news channel ran more than 26,000 jobs with more than 10 continuous integrations with sequential scheduling. The company had issues with identifying a way to unify the coding process and monitor the continuous integration consistently. Also, the existing jobs took up to more time, that is, up to 60 minutes to schedule and perform its task. Docker allowed BCC News to eliminate job wait times and run jobs in parallel. It also gave the users the ability to work in a more flexible CI environment where entire code processes were unified and stored in a single place. However, Docker succeeded in spreading up the whole continuous integration process.
So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms, and then finally, For space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution part that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the Compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you can be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked to how to create a Docker container. So let's go through what that would look. And we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have a Docker registry is an open source server-side service used for hosting and distributing Docker images. Whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix. You could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Docker file, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80 80:80 as our command line.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility, but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. So let's start with why are DevOps skills crucial? Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well-versed in Linux, as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Docker file efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Docker file creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps project. We deploy applications seamlessly across Azure services like App Service, virtual machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, containerized web app deployment on GKE, scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes Engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, mastering version control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, effortless deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, Mastering Terraform Project Structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.